Hello, hello, good morning. How's everybody doing? Whoa, okay, that's the energy I'm asking for.
No way. You came back?
Well, I also know some people just came here as their first day. So welcome back, everybody. And for people who are new, welcome to AI Engineering Miami, day 2.
Okay, some quick questions. Who learned something awesome yesterday that they can't wait to try very soon?
Ooh, I see hands.
Okay, who made some new LinkedIn connections?
Well, I see hands.
Who made more than 5 LinkedIn connections?
Hands.
Okay, I'll take note of that.
Would
I hope you get replaced by AI.
Wait, who's that person?
All right, and who got drunk last night? Don't be shy. Show me your hands. Who got wasted? Never mind. I'm surprised you made it back. Anyways.
Well, because I'm so excited about the agenda for today. So no matter how much you drank last night, we have a great lineup of talks today. So ranging from G2I, our organizer, all the way to Cursor. So a lot of great talks. Actually, I'm super excited about one talk in particular. It's super futuristic, but I'm not going to spoil it for you. So stay tight, and at the end of the day, I'm going to ask you to guess which one was the one that I'm most excited about. So just keep tuning in and find out all the talks that we have organized for you today. Okay, so I have a question for you all. Who is a world-class engineer? Yes, that's the confidence that I'm looking for. Every single one of you actually sitting in this room is a world-class engineer. And also the person sitting next to you, even the people who don't like other people, are also world-class engineers. So I want you to really take this moment to learn more from all the talks today, really try to be that world-class engineer that you truly are, and also talk to other people and make connections so that together we can all build a better future with AI. So that is the goal for the conference for today, and I'm just so grateful that every single one of you is here and you are making connections and making that possible for us.
I forgot to ask one question. Who's loving the MCs this year? Good. Who's loving the MCs? Woo! Thank you all.
Yeah, well, we're going to keep the energy for our first speaker of today, David House. Iman, what do you think about David House?
I'm really jealous of his jacket. You'll see.
Well, so David will be talking to us, representing G2I, which is the organizer for the conference. He's going to talk about how we're transforming programming mindsets. So he's going to give us some case studies in agentic coding adoption. So relevant to every single one of us. And I can't wait to introduce David and let him show off his jacket. So give it up for David.
Good morning, everyone. Hi. So I am a software engineering manager, but my background is actually in mental health counseling. I've always tried to figure out how to marry these skills together, and recently I saw a unique opportunity. I've been hearing about all of these people adopting coding agents, but there's also a lot of anxiety, a lot of fear, a lot of existential dread. So I wanted to learn more about that. Also, this is my very first conference talk, so please clap. So there's a lot to learn. How are people adopting these tools? And I got into the weeds with different interviews, people on the team. I asked them questions about how they adopted the tools, what their experiences were, what their feelings were. And what I ended up learning about was a model of successful adoption. Our first case is Ava. Ava's first experience with AI was with ChatGPT. She used ChatGPT for coming up with ideas for family events, kids' activities, all kinds of things that she could review herself and trust the output. She was the only one who needed to sign off on it. But when it came to work, she held a very different standard. She didn't copy-paste code. She didn't trust the output. And contrary to her work with AI with her family, there were other reviewers that she was very mindful of. She was very mindful of her reputation, and she didn't want to ship slop. However, when she joined G2I, the project was very different. I'll tell you more about how the project was structured later. But she joined a project where agentic coding was the expectation from the beginning. And the whole project was built around agent use. She learned that different techniques for working with agents could produce better output that she could actually trust. And she realized that a lot of things had to change about her development workflow. After months of using the prescribed workflow, she internalized those lessons enough to be able to create a sub-agent for herself for a more specialized testing pattern. So when I watch YouTube videos about AI, I hear slop cannon and I hear skill issue. It's really easy to polarize between the two, right? But like, if you're someone who's saying skill issue, maybe you were someone who said slop cannon. If you are someone who's saying slop cannon, maybe there's something for you to learn to get to the point where you can say skill issue. The point I'm trying to make is there's something in between those two poles, and that's what I'm really interested in. I think both are true, right? And when you learn how to work with AI, then you can start to differentiate how to avoid the slop cannon and hopefully how not to be arrogant about it. OK, I agonized over this slide for a long time, but now it's my favorite. Here's my claim for all of you, is that for a beginner, an agentic framework should constrain their input. A beginner doesn't know when they're going to make mistakes. But for an expert, someone who has spent a lot of time with agents, someone who's internalized the development practices of how to work with them, an agentic framework should actually amplify their input. So an agentic framework should shape the input of the human in addition to improving the agent's output. What I suspect is that these skills are not intuitive for any engineer. Agentic use was not part of any of our education, so we can't be expected to know it. Let's talk about what happened at G2I. So the case studies here are all from a very specific project at G2I. Everyone was onboarded to the same agentic framework, which relies very heavily on documentation and staged handoffs. It starts with a /brief skill, where the agent assumes a product manager persona, interviews the user, and the output of that conversation is a product brief. That product brief becomes input to a /spec skill, where the agent assumes the role of a technical architect, again, interviews the user, and the result of that is a technical specification. That's provided as input to the /code or /test-driven development skill, where both documents act as very specific, very well-reasoned prompts with embedded judgment from the engineer. And then we close with the /review skill to make sure that the agent covered all of the implementation as defined in the doc, and then a draft PR skill to save you a little bit of time and spend a few extra tokens. But don't get distracted by the framework. I'm not here to try to tell you that this framework is better than any other. And I'd probably go as far as to say that most frameworks are pretty much doing the same job. I break that job down into 3 things. Number 1, revealing the hidden practice of agentic coding. Number 2, making the work of the agent reviewable, both its reasoning and its output. And number 3, training the engineer in effective delegation with the agent. A beginner might throw one prompt to rewrite the whole code base in Rust. But a more experienced engineer will know to take that step by step. Our second case is Lucy, who has 4 years of engineering experience. Lucy got started with coding agents in a prior job to G2I. She had success writing a migration script from, if any of you know about Vite and know about barrel files, you know exactly how hard this is. The agent could automate the boring stuff, and the agent could build a script that encoded a lot of judgment. Then Lucy's success on that project motivated her to give agents a try from the very beginning with a very complex personal project. But she ended up with a lot of duplicated code. Code that she didn't understand, code that was too much to review. And this was also using technologies that she wasn't unfamiliar with. So it was very challenging to work with and very demoralizing. When she joined G2I, the framework that we used told her something that felt obvious in hindsight, which is that you have to tell the agent to do the right thing. You have to tell the agent to write tests. You have to tell the agent to run the tests and make sure that they're passing. So she learned that the practice of agentic programming is building the judgment you have about how to be an engineer into prompts and into the review mechanisms. She said that she does not take for granted that the agent will do what you want. So Lucy used the G2I's framework for months, but she doesn't use the framework anymore. Now, Lucy's method is much more interview focused. She'll spend a lot of time going back and forth with the agent, not necessarily using a strict prompt flow, not necessarily expecting a specific documentation result. But she trusts that during this interview, she's able to build in as much judgment as she possibly can. She's able to steer the agent during the interview. And she also doesn't necessarily trust herself to be a perfect provider of information. So the interview loop helps her remember the things that she had forgotten to say. Next case, Antoine. Antoine's been an engineer for 15 years. He's a startup founder, and he is meticulous. Antoine is someone who has a reputation at G2I for being able to get anything done, no matter what it is, no matter how hard it is. If it's something we have to do, Antoine can do it. So we end up being very careful about where we direct his attention. Antoine's skill and attention to detail meant that when he was working with agents, he was very focused on the results. His early experiences with agents were very disappointing. He realized he needed to be vigilant, and reviewing the code as output taught him that he needed to be very cautious. So he swung from early exposure with agents to hypervigilance that diminished the value that he could get from coding agents. But when he joined G2I, the TDD skill significantly improved the output, which improved his trust, which allowed him to trust the agent to do more, which gave him better results, which improved his trust. And he's still skeptical, but he's tuned his skepticism to be more context-specific. He now continues to use the agentic flow, but to hear him talk about it, he can't necessarily describe how the way he does it now is different than the way that he did it prior. He talks about the 100 nuances and ways that his judgment built over time, working with agents, reviewing their output, has built skills that are essential to how he writes code today. Our third case here is Dale. Dale's been an engineer for about 4 years. His first experience with AI was using ChatGPT for coding. I was actually working with Dale at the time. We were both working in a PHP code base. Neither of us were very good at PHP. And I was like, hey, Dale, you can use ChatGPT to explain collections. You can use ChatGPT to explain Laravel. It will have infinite patience for you and infinite time. I had lots of patience, but I didn't have a lot of time. So he asked it for help with code, understanding it, but not actually writing it. Similar to Ava, Dale was very concerned about reputational risk. I also didn't trust that the agent had enough information. So with ChatGPT, he knew that the agent, intuitively, he knew that the agent couldn't read the whole code base. So he was unsure always, every single time, whether or not the output was misaligned based on the available context. He was also more junior at the time. This is a few years ago. So he didn't trust that he could actually validate the correctness of what was being output by ChatGPT. When Dale joined G2I, he was a little hesitant, but it was clear that it was clear to him that he needed to figure this out in order to be successful. He had some early successes with agents, but went a little off the rails and ended up with a 10,000-line PR. He figured, OK, well, the agent can do the whole epic, right? So let's just have it do the whole epic. And then learned very quickly that that's not necessarily a very good idea. He learned to narrow the scope of his delegation and make sure that he could, that the agent wouldn't get away from him. Now, differently than, I think, Antoine, differently than Lucy, Dale has moved away from the framework, but his way of prompting today is very, very similar to it. Instead of using the skills to generate a document that is then used as input, Dale writes the entire document himself. And he encodes the same guardrails and judgments that the framework made sure to include by default. He knows now intuitively to include them himself. And he can then use his judgment to be even more precise about the guidance. So then he spends 20 minutes, in his own words, writing this prompt. But he trusts the agent well enough, and he trusts his own delegation skills well enough, that when he hits enter, he's very happy to walk away and come back to a PR that he'll review as though it was a PR from his teammate. So I think the point I'm trying to make is that successful adoption is about internalization of these practices. The engineers, when they started working with agents, described feelings of disempowerment. They described feelings of sort of reacting to situations, not necessarily steering the output. But as the engineers learned more about agents, they learned how to be the ones in the driver's seat. You could say they learned agency. But what about junior engineers? When I hear people talk about junior engineers, I tend to hear one of two things. I hear if you find a junior engineer who has already learned AI, that you're set. It's fine. Thanks. But if you don't, then juniors are screwed. So again, it's another one of these polarities. Either you find someone who's already learned the skills, or you don't know what to do. So I think we can do better than this. Andy is a member of our team, fresh out of college. His whole experience with AI was being told not to use it by his faculty. But his tutors encouraged him to be a little more nuanced. His tutors had to coerce him into using AI like a tutor, because he was spending a lot of time at the tutoring center. He was open to having AI augment his understanding, but all throughout school, he wrote every single line of code that he submitted for his assignments. When he joined G2I, it was a total culture shock. Andy started to re-examine his hesitancy when he saw senior engineers with much more experience than he had finding success using agents. But he didn't necessarily trust himself to be a guide, and for good reason. He hadn't spent a lot of time in the field, he hadn't built a lot of software, he hadn't made the mistakes. But what he found made him much more successful was when he brought a senior engineer into the loop of his work. So if you remember, we have this agentic framework at G2I where you use skills to do document handoffs. He would take the documents before he gets into any code, put just the documents up for PR, and get reviews from senior members of the team. That allowed the senior engineers to encode their judgment into the documents, which made the docs more successful, made his implementations more successful, but also served as a teaching opportunity and a mentorship opportunity. Also, Andy's looking for his next gig. So let me know if you want to meet him, but don't wait, because he's already interviewing. So don't give up on juniors. Andy became a steady contributor in 3 months on the team, despite being the only junior engineer on the team. Junior engineers still need mentorship. But agents expedite that because they can serve as tutors for the engineers when all the senior engineers are busy with their own implementation tasks. And agents expedite that mentorship as well because the documents that the junior engineers create can serve as high-level, high-leverage review artifacts, where then the implementation can be much more successful, building the confidence of the junior engineer. To quote one of his colleagues, quote, "I was shocked to hear this was your first role out of school. You fit right in alongside folks with 10 years of experience. That's incredible." So many people are convinced of software engineering doom. Maybe we're on a timeline where the profession of software engineering becomes irrelevant. Maybe that's true. But what if everyone trying to predict the future got it wrong? What we do today matters. I want us to look back on how we're approaching this work and how we're approaching our field from the standpoint of opening doors for everyone. I don't want to give up on the hesitant. I don't want to give up on the conflicted. I don't want to give up on the people who haven't had that experience of being shown how to be successful with these tools. I'm not interested in leaving anyone behind. So you can try the framework if you want. But again, don't be distracted by the framework. Use BMAD. Use RPI, or the acronym that add more letters to RPI that I can't remember from yesterday. Crispy, yes. Try a framework that slows you down so you can review the output.
Thank you, David. So everybody wants to run the latest model, right? The fancier one with more parameters. And that ends up being very costly, and we have tremendous debt, and that's latency debt. The next speaker is here to save us from that debt. Please welcome to the stage Sarah Chieng, Head of DevX at Cerebras.
Sweet. Well, good morning, everyone. Me and my team, we actually just came from California, so it's a nice 6:30 a.m. talk. But it's great to be here, and I'm excited. All right. So recently, I've been learning a wide variety of new vocabulary words. Cogitating, words like reticulating, schlepping. Some of you know where this is going. And the reason I've been learning all of these words is not by choice, but because every time that I try to use Claude Code, I get these words for like 35 minutes. And I also get, writing and waiting and thinking, but we already know those words. And if any of you guys have been playing around with LLMs or using them recently, you've probably had a pretty similar experience. Slow code generation, we write massive prompts, we submit massive diffs, or honestly, we hit enter and we go on our lunch break, and we come back and pray it's done. It's frustrating, it kills the sparks and joys of AI coding, and today we're going to talk about why this is all happening. So my name is Sarah Chieng. I am the head of developer experience at Cerebras, and we're building the world's largest and fastest AI processor. And a big part of my job is introducing developers to fast coding for the very first time. And it's a very exciting job because oftentimes we get a lot of oohs and ahs and, oh my God, this exists. And outside of Cerebras, I also create content on YouTube and TikTok and Twitter. So before we dive into everything that is frustrating and going wrong, let's talk about all the amazing things that are going right. So in the last few years, we have seen models get so much bigger. We have gone from models that are 0.3 billion parameters to over 1 trillion parameters, and a lot of these are open source models too. And as you can imagine, this also means we're getting much smarter models. Context windows are also getting much bigger. If you so desire, you can shove millions of tokens worth of context into your model. And what's exciting is that we're actually seeing developers use this context. So this is a study by OpenRouter and A16Z. OpenRouter is a unified API layer for LLMs, and they did a study where they sampled 100 trillion tokens worth of real-world tokens across different use cases and capabilities. And what they saw is that input token lengths have gotten 4 times bigger in the last year alone. And on the flip side of that, output tokens have also gotten so much bigger. So the number of output tokens per prompt has also increased by 3x in the last year. And we can see this is because not only are our models outputting the final answer, but we're also outputting reasoning tokens. And so reasoning tokens are the intermediate tokens that a model will output when it's thinking step by step before producing the final answer. And we can see this coupled nicely with the rise of reasoning models as well. And so we've had a lot of incredible reasoning models over the last year. And so our models are getting smarter, our models are getting bigger. All of this is wonderful news. And this, my friends, is quite literally the best technology that humans have ever built. And so now let's look at this best technology in action. This is Opus 4.5, doing a very simple HTML snake game. Sorry, pool game. Awkward. You all wish you could go leave for a snack, but you can't. And if this was in Claude Code, this is where we'd be learning new vocabulary words. This goes on for minutes, and I won't bore you. But I'm bored. You're probably bored. And as it turns out, if you've been playing with LLMs, you've probably had a very similar experience. But unfortunately, with all of this exciting innovation, there's a very unexciting side effect. And I like to call that side effect latency debt. So while we've been innovating on all of these models, they've gotten bigger, they've gotten more intelligent, we put more tokens in, there's more tokens out, we have accumulated a hidden cost while optimizing our models faster than our infrastructure. And what I mean by that is that now if we look at we've improved on so many fronts, but now let's look at speed. Over the past 2 years, we look at the Gemini families, we look at the Claude families, the Sonnet models, our speed has stayed the same. We have always stayed between 50 to 150 tokens per second. And now remember that even if your speed stays the same, if the number of input tokens increases and the number of output tokens increases, then the total time that it's going to take for your prompt to complete is also going to increase. And when that increases, the developer experience decreases. And so now, this is the exciting part. So now is when I get to tell you that all of this is about to change. In fact, it is changing. We've accumulated so much latency over the years, and now we have a solution. So about a month ago, we at Cerebras and OpenAI partnered up to release Codex Spark. It's the first state-of-the-art coding model that can generate code at 1,200 tokens per second. And to put that into perspective, that is 20 times faster than anything you're seeing here. And not only that, but Codex Spark is just the first of many future models that we can expect to be a step function faster than anything that we've been frustrated with before. And so not only are we unlocking new capabilities and workflows and use cases, but this also fundamentally changes how we as developers can interact with the coding model. No longer do you hit enter and you leave, but now you can actually sit down with the coding model, treat it like a pair programmer, verify the outputs, steer it. No longer do you have to generate machine levels of code, develop technical debt. Now you can actually verify your code. You don't have to create bad code. And so now let's look at that same graph again. And let's look at Codex Spark. It's so much faster that we had to adjust the y-axis. And remember, Codex Spark is just the first of many future models that we can expect to be a step function faster. And at this point, it's a complete regime change. We are entering a regime of fast inference, and now we are entering a regime where the coding model can code faster than we humans can keep up with. Now we are the bottleneck. And so why is this happening? We've been accumulating this latency debt for so many years, but what is suddenly happening right now that is making all this possible? So the exciting part is that it's because the entire inference stack is getting optimized all at once. And many of you in the audience are probably contributing to this in your day-to-day work. And so let's break it down. Let's take some moment. Let's start with the very bottom, the hardware. Hardware is the physical reason that speed is possible. It is the inference and training, everything, the physical device that all of these workloads are on. With hardware, one of the biggest considerations is what I like to call the memory wall. So during inference, we have memory movement, but we have the movement of weights, KV cache values, et cetera, between the memory and the actual chip. On traditional hardware like the GPU, all of this memory is stored off chip. And so we're constantly moving all of these values between on and off the chip. And that memory movement is why the hardware is accounting for 50 to 80% of the total inference latency. What we're now seeing newer approaches to is we're thinking about how can we reduce this memory movement as much as possible. This is an example by Cerebras building our own version of the AI processor where instead of storing our memory off chip, all of our weights and activations, KV cache values, we're storing them on chip in a distributed SRAM so that every single core that's actually doing the computation has direct access to all of the values that it needs. Even more exciting, the commercialization of disaggregated inference. This is why NVIDIA bought Grok for $20 billion a few months ago. And this is also why Cerebras and AWS just released a partnership to serve the Cerebras Wafer Scale engine and the AWS Trainium together. What disaggregated inference is? So in traditional inference, we have two steps. We have prefill and we have decode. And prefill is when we're actually processing all of those input tokens. And we can do this in parallel. We're embedding them and adding them to our KV cache. So this step is compute bound. Our second step, decode, is when we're actually generating every output token, token by token. This is sequential. and this is memory bound, like what we were talking about before. And so we have two different steps with very fundamentally different requirements, and we've always been serving them on the same piece of hardware. Well, no more. And now we're splitting it up so that decode is happening on memory-optimized hardware, and prefill is happening on compute-optimized hardware. And now let's move up the stack, the model architecture. There's so many ways that we have adapted our models for the hardware that we have to run especially well on the hardware that we have. We think about model size, shape, the layers, the dimensions. And so MOE isn't particularly new, but this is a great example of one way that we're doing that. So MOEs, or mixture of experts, is where instead of activating the entire model for every single token, we only activate a small subset of experts. And what this gives us is the intelligence of a much larger model for the compute cost of a much smaller model. Again, we're always thinking about memory, just like the hardware thing we were talking about before. But more recently, what we're seeing is that models, researchers are building on top of MOE. So we're seeing a lot of exciting new advancements for how we can make our models fit even better on our hardware, especially for speed. And an example here is REAP, Router-Weighted Expert Activation Pruning, mouthful, where instead of activating, again, the entire model, we're looking at a specific use case, we're seeing what experts are activated, and we're just axing and removing and pruning the ones that we don't need. And now the final layer of the step is inference optimization. Again, this is where a lot of you are probably working on. Philip gave a great talk from Base 10 yesterday. This is where companies like Base 10, Modal, Together, Fireworks are all working. And one of the biggest considerations at this level is the KV cache reuse. So by storing and reusing previously computed token representations, we don't have to recompute attention over the entire sequence every single time. And so all of this are investments that we've been making, and all of this are investments that we're slowly starting to see come to fruition. And it's incredible. We've had this latency debt that we've accumulated for years, and now look at where we're at now. So now I want to show you what a state-of-the-art model looks like on a state-of-the-art AI-optimized hardware. Again, it's the same two-player pool game, but this time it's running on this. It's running, this is the Wafer Scale Engine 3, Cerebras' own version of our hardware, and so it's not running on GPUs. And this is Codex Spark inside of Codex. And it's done. And there it is. And if you still don't believe me about latency is real, you probably do, but just to be sure. Let's look at the money. Let's look at where the biggest companies in the industry are putting their money over the last 6 months. Number one, Google versus NVIDIA. Google releases a TPU 4 times faster than the NVIDIA GPU. This is NVIDIA's biggest customer investing in the infrastructure level. We have Google and Anthropic. Then what happens? Anthropic comes in and buys those TPUs, tens of billions of dollars worth of it. As I previously mentioned, NVIDIA bought Grok for $20 billion. This was NVIDIA's biggest purchase ever. Grok had been building the LPU, their own version of a faster AI processor. And most recently, and most excitingly, not biased at all, OpenAI buying Cerebras hardware. And this happened a few months ago. Codex Spark was the first model that they released in this partnership. And again, we can expect many future models to be this step function faster latency. And so we can see all this memory movement because what's exciting is that latency debt has been slowly accumulating. We saw the biggest players not only recognize latency debt, but invest in latency debt. And now we're seeing that investment pay off. And so now as we think about these new eras that we're entering, and we're thinking about entering this new regime where the model codes faster than we can keep up with, I want us to take a little trip down memory lane at previous eras that we have. So in 1985, it's a history lesson now, we switched from custom hardware to CPUs. Why? Because our workload changed. We went from scientific simulations and mathematics to needing creating highly programmable software apps. In 2003, our workload changed again. Now we have machine learning and graphics processing. So once again, our infrastructure changed. We went from CPUs to GPUs because now we cared about high levels of parallelization. Where are we now? We're in 2026. And once again, our workload is changing. We have multi-agent systems. We're building 500 plus agent swarms, human in the loop, agentic workflows, and once again, our requirements change. And what's exciting is that we've already seen people invest on this level. We've seen people invest in the infrastructure. And now, right now, is when all of that is paying off. I cannot communicate enough how exciting it is to be a developer right now. Not this year, this month, this day, because we're right in the middle of a step change as we enter a new paradigm where the coding and developer experience is going to get so much better. And the thing that I want to emphasize is that it's not just about faster models, but it's about the fact that the developer experience is going to change. The way that we as developers interact with the models are going to change, and our ability to no longer produce bad code is going to change. So thank you guys so much. My name is Sarah Chieng. If you have any credits, if you need any credits or have any questions, reach out to me. My handle is Milks and Matcha across the board. Thank you.
All right, that was a great talk from Sarah. Okay, so our next speaker is Lech. And then fun fact, I think Lech might be the most likely to survive if there were a power outage here, because he has all sorts of gadgets with him. He even has a flashlight, he has a pointer, a laser pointer, and his LLM models are deployed locally on his mobile. So even if there's no Wi-Fi out here, he will be able to make it out alive. So I'm so excited to hear how he's able to do that. So Lech is going to tell us about Ambient Generative AI and how he deployed latent diffusion models on his mobile phone NPUs. So welcome on stage, Lech.
Hello. Okay. I'm so surprised that people are still so much inspired by nature. Actually, we are just trying to mimic leaves, mimic birds, mimic how they just fly. So, and yet we also try to mimic one of the most fundamental physical law, which is randomness. My name is Lech Kalinowski, and I am a physicist. I work in CallStack. It's a Polish company. And today I want to present to you my original research about the deployment of the diffusion models on mobile. So this is a part of the bigger project, which is related to hyper user experiences. And I'm working in the Research and Development Center. That means we just try to innovate the part of the user interfaces and try to push the boundaries of the implementation of AI in that area. So randomness is really well known and used across many of years in algorithmical computer science. So one of the most famous algorithm is the Monte Carlo method, when you can just, for example, calculate the area of a circle, or you can just calculate or simulate the chain reaction in nuclear physics. And today, I just want to tell you why I just simply do this, and where I just get my inspiration to build that type of project. So currently, the biggest world labs in AI works with randomness. What does it mean? We just try to optimize and build LLMs which are fast and cheap. So for example, Google just introduced TurboQuant, and at the core of those algorithms there is randomness. Some kind of other examples, Mythos cost like $120 per 1 million tokens, and that is really expensive model. This is why we are just looking for the fundamental laws and try to be inspired by them to build better, faster, and more optimal models. This is the reason why I just wanted to try to deploy the diffusion models on a mobile application in the really best possible optimal way. So I started to think how I can do it, because as you probably know from yesterday, and Google just showed it, the diffusion models and the picture generation is really, really difficult and computational heavy. That means you need to have a huge GPU to generate. It takes a lot of time. So this is a couple of constraints. That means you have to on your mind the thermal profile of the program. And actually, I just get an idea. Maybe I can use the NPU, neural processing unit, on the smartphone to deploy there directly in a diffusion model, and then try to run out a diffusion inference there. But it's not like enough. The main idea was also to get rid of the full pipeline of the change the text through the embeddings and building the full prompt through it. So I just throw it out and get an idea to use direct numerical value from an ambient sensor. Of course, here is an example. That means it can be like different sensor, it can be accelerometer, it can be something different, but actually it works. So what I did, I just designed a full pipeline with the zero cloud APIs calls to the outside not local LLMs, and I build a full measurable system to check it out and prove that diffusion models are possible on the local mobile devices. Here's the pipeline. That means the most important thing is the latent update. And as you probably can see here, there's a stochastic perturbation scale, and the randomness here is implemented. One more thing. I don't know if you just all know what the diffusion really is, because the diffusion is made by adding a noise to our data sets. For example, we have a data set with a lot of the, I don't know, maybe dog pictures. And we are just adding layers of noise there, and then coding, like in transformers, the model. That means we are just minimizing a function, and then we have a huge noise of the latent space representation. And to get an inference, from the other side, we are just decoding that noise. That means decoding that randomness. And for that, we also use, like in regular LLMs, we also use the transformations. That means we are decoding, denoising the information there, and we are doing it iteratively. That means all of the information requires really requires a lot of computer power. The logic is quite simple. That means the first ambient sensor, then mapping, after it conditioning. That means the full pipeline to get those data mapped to the latent space, and the latent update function runtime session, and the full telemetry to measure all of the, let's say, results. Here's a bit detailed view of it. Actually, the full project was full application is designed in the blocks. That first block is an input and the coding layer. That means this is not that simple to get the raw data from the sensor and map it to the latent space. So the full first mapping is that we are getting the ambient light sensor, then build an hysteresis on the top of that, build a profile mapping and the full normalization, and then building the latent vector. So I also build a full fallback. That means to be sure that I'm just running out of memory there. If some kind of thermal incidents rise, then I just cut off the whole application because I didn't want to lose my phone. Here is the API and the native Android bridge, which gives me opportunity to deploy the model directly on the NPU. And I also used an ONNX runtime to do it. The next part is the full diffusion line, where I have Android native ONNX session manager, and here is the model. And this is the unit, various auto encoder. That means the part where we are just encoding the, let's say, prompt. Then we have the unit denoise loop. That means the core of the diffusion process with the 8, 16, and 24 steps. And then we are just decoding it to the tensor and RGB picture. At the end, I also collect, the pictures itself, all of the artifacts and the metadata. And at the end, we have the gallery and full telemetry. Okay, I think this is the funniest part of my today's presentation. Let me show you first the simulation on a computer, just before I show you working application on my phone. Okay, this is how it looks like. It's not maybe impressive at that stage, but give me a second. Okay, so I can change the simulation of light and get an instant inference on the device here. So let me also show you the whole measurement part. That means we have full metadata captured, ambient light, smooth light stabilization, temperature, and everything which is necessary. That means one of the most important parameters for me was the stabilization and the latency. Okay, let me show you right now how it works on the smartphone. So here's my private phone. It's not sponsored by Samsung. It's my private one. Actually, let me. Probably you can see my screen. I will switch off all of the internet connections to the flight mode. We will be sure then it's not the fake. Okay, and here's it. Maybe I would just brighten it up. So I'm really glad that there's a lot of lights there because it's working. Here we have a change in lux. That means we are just capturing all of the data from sensor. And this, what you are just seeing right now, is the full inference of the diffusion model deployed on the NPUs. It works really, really fast. I know this is not like a pixel-wise representation, because to do it really optimal, I need to cut off whole of the part of building real text to embeddings prompts. And what is really important, as you probably can see, it is extremely fast and it is really stable. That means with this, you can build some kind of other different applications and use it to, I don't know, try to build some kind of different pictures, or you can just even try to build an animation with this. And this is not something which will kill your phone at the end. Okay, let me show you briefly the results of it. So here we have parameters I captured, artifacts, how many artifacts through. This is the single experiment. Robust latency is around 600 milliseconds. That means really, really fast. The full inference, it's cost not that much. It's really stable. That means you can use that type of architecture for your future projects. But I didn't want to finish on the, let's say, weird RGB colors on the phone. And I just forced that applications to build something nice here. And I decided to build, just before the conference, I decided to build something more. And give me a second, I will only just will find an application for it. So I decided to generate a heart and try to force, with some geometrical tricks and constraints, and I try to force the model to generate a real heart with the model. And actually, yeah, that works. So I'm really happy that I was able to do it, and I'm really happy that that I can show you the recent progress on the hyper user experiences today to you. To wrap it up, I think you probably should think about the NPUs and try to use it wherever possible to optimize and speed up your applications, because all of the modern mobile phones already have it, but I think not everyone just uses it in the modern development. We can, for example, can build an animation with this, and it's a really good option. So I think I just point you out that you can use it as an unconventional application, and it just waits to be discovered in your projects. And if you just want to learn more about CallStack and our work, because we just, in our incubator and R&D center, we already just open source quite a lot of, let's say, artificial intelligence projects like, for example, evaluation benchmark for React Native applications, then grab a code and take a look there. Thank you very much.
Great, thank you, Lech. Quick note for our coming up speakers, please show up at the G2I booth at the expo hall so they prepare you to bring you to backstage. And I promised Lech and David that I would compare their jackets. Yeah, well, he has a suit. Those of you who liked David's jacket, please make some noise. Okay. Those who like his. I think we have a winner. All right, so we have a break right now. Please get your coffee, but be back here around 10:55 as we have the next talk starting then. Thank you.
Test, test. C. 1, 2. Testing, testing. 1, 2. 1, 2. C. Hey, hey. Testing mic. 1, 2. Check, check. Check, check. C. Testing. Left 2. Check, check. C. Hey. Test, test. C. Testing. 1, 2. Testing. 1, 2. Test, test. Test, test. 1, 2. Testing. 1, 2. C.
Ladies and gentlemen, please take your seats. Our event will start in 5 minutes.
Hey everyone, welcome back. I would like to take a moment to thank our sponsors, without whose support this would not have been possible. CodeRabbit, Mintlify, Cerebras, Sentry, Cloudflare, Tailscale, Modem, Appify, Auth0, Google DeepMind, City Furniture, and Encrypt AI. Let's hear it for our sponsors, shall we? Our next speaker, I asked him in the back, what's the craziest thing you do? He said, I code all day, but I have a foot pedal. It's like a productivity hack, apparently. A foot pedal, when he presses it, it starts the voice commands, and he can talk. Turns on the speaker, I suppose?
No, Whisper Flow, if you know what that is. Like,
There you go. I don't know what that is.
it's like a voice to text.
You have to explain that during your talk then. So he does that. Also, he tries to take, did I say it, 210 grams of protein a day?
You're giving out all my alpha.
All right, it's my pleasure to welcome Tejas on the stage. And he's going to talk about a lot of inference optimization. He's worked in Tesla Autopilot before, and now he has his own startup. And his focus is inference optimization and how to make code gen more optimized. There you go. Thank you.
All right, one sec. Hey, Dad. Dude, I swear I practiced this before. Sorry, one sec. Yeah, I'm not seeing anything from HDMI. think so.
Okay, as Tejas is setting up, here's a reminder also with the background music that there is an after party today. So if you didn't get a chance or you're held back from getting wasted last night, tonight is your chance. It's at 7 p.m. at Thrill Show. And with that, I think Tejas is ready.
Cool.
Take it away.
Yeah, hey everyone. I'm Tejas. I'm the founder of Morph. And today I'm going to talk to you about subagents and specialized models. So you might remember this. This happened like last year where Trump went to the White House. He was demoing a Model S from Elon, and he said, wow, that's beautiful. Everything is computer. I thought that was great because it's actually accurate. Like everything is actually computer, right? Like even the Windows inside a Model S is like a mini computer. And so what I'm getting into now is this is Andrej Karpathy's sort of software 1.0, 2.0, 3.0 paradigm. So if you remember software 1.0, this was humans writing code that programs computers. Software 2.0 was weights programming neural nets, which is sort of like a flexible fixed function computer where you can do things like detecting stoplights. Software 3.0 was humans using prompts to program LLMs. But a new primitive has appeared. So now we have subagent, task, and composer as a background search tool, and then cognition with Swegrep. So what I think is the next sort of step past software 3.0 is what I call software 3.5, which is sort of agents prompting other agents. You still have the human at the top prompting that main agent, but you sort of have, some people call this agent swarms. I think that's too vibe codey of a term. So yeah. And so essentially what a subagent is, it's super simple. Its simplest definition is just using a separate context window for a task. This has been proven to be useful coding agent performance. So yeah, so it's sort of this third brand new primitive. I think the first two were system prompts and tools. The question becomes, should subagents be specialized models or should they be general models? And I think the right answer is that it depends. But the interesting part of this talk is when it's actually specialized models. So first, the cost of using a frontier model. So frontier models are really good, especially at coding and reasoning, but they take a lot of compute and they're super, super expensive. So they're not really great for every task. So why should you even bother considering a specialized model? So from a macro perspective, we have this huge compute scarcity crisis right now where like there's no H200 or B200 capacity across the board if you look at GCP or AWS. In fact, right now I even have agents in the background trying to find some capacity. But basically this is a macro pressure to like pressure people. This sort of macro pressure pushes us to specialized models because then you can use less compute to do a task to like the same accuracy. This is just a graph saying the same thing. Basically what you want to do is the minimum compute to do a task well. And this sort of just arises from this compute constraint. And so our answer at Morph is we basically do specialized model and specialized inference. And so we think stuff like code search and context compression should move to specialized models, whereas stuff that still needs frontier compute, like coding, planning, and reasoning, should stay frontier. So one of the things we can do when we specialize a model is that we can do things that you wouldn't do to a general model. For example, a frontier model lab right now, they typically won't train on a parallel tool calling harness because you get this chronic forgetting problem where once you do RL on this parallel tool calling harness, you start seeing regressions on sequential tool call performance. And so that's an example of a trade-off we could make that a lab might not want to make. And so that's what we do for our code search model. Our code search model can do up to 12 parallel greps, reads, or list directories, up to 6 turns. And it can do this very fast on an inference engine that we make that's designed for this workload, which is super prefill heavy, like up to 80K of token input and like around 200 tokens output. So another model we have is our compactions model. It's basically a model that's trained to compact context at 33,000 tokens per second. Fast apply is our diff apply model. And yeah, so we build these models because I think coding agents spend most of their time doing things that don't actually need frontier compute. And this is like code search, compaction, and applying code edits. And these happen thousands of times, but just aren't actually stuff that needs frontier compute. Yeah, so how do we make them good? So good for us doesn't just mean like building something that gets like a good like F1 score, for example. You have to train these to be a good subagent, not just a good model. So what that means is for us is that when we do RL, we train to sort of minimize this randomness that you get when you introduce a specialized model. So like, let's say you have Opus at the top calling one of our code search model. One of the problems when you have this sort of setup with a separate model is that Opus might have an assumption that your model is more capable than it might be, or that it works in a different way than it actually does. So during RL, we have to train to like minimize this randomness. That's like one dimension in which you have to cover when you make a specialized subagent. And so how do we make these fast? So one of the most common ways people make models fast is called speculative decoding. Speculative decoding is sort of it's sort of a thing, first of all, because you have this like massively parallel machine that's a GPU, and you have this like super sequential architecture that is the LLM. So at the top there, you see traditional LLM inference where you have to generate one token at a time, regenerate KV and all your stuff, and then to generate the next token. With speculative decoding, you sort of switch this, so you have some heuristic to make like a guess of like, let's say 6 tokens, and then you have your massively parallel machine, the GPU, just verify that those 6 tokens are correct. And that time is linear to generate 1 token or verify those 6 tokens. Those both take the same time. And so traditionally with speculative decoding, you can have a smaller model, like a very, very tiny model, like a 0.7B, do these predictions, and then just have the big model that's like 3 trillion, verify them. But you don't actually have to have a small model. You can do it heuristic based. You can do it whichever way you want. You just need some sort of way to get those guesses. Another common method is disaggregated prefill. That's basically, prefill is everything that happens in the time to first token. Decode is everything that happens after that. So a common thing we're starting to see happen now is disaggregating those workloads into separate chips. This is sort of a thing because NVIDIA's NVLink is so good. NVIDIA is starting to do this now with Grok, where Grok is going to be doing prefill, and traditional NVIDIA GPUs will be doing decode. It also works if you just use NVIDIA for both. But yeah. Another way is if you write kernels. Kernels are notoriously hard. It's a very fast-changing field. One day it's QTSL, the next day it's Mojo, the next day it's Qtile, and the next day it's back to QTSL. And so this one is the hardest one out of all the 3. But these are the 3 main dimensions in which we do our inference optimization. For the really technical people out here, I think where the future is going is actually like disaggregating further, where you take attention operations out into its own machine. So you're might even have 3 or 4 separate chips, each specialized for like prefill, decode, attention. But yeah, a lot of first principle thinkers would think this is really stupid though. Like Jim Keller and these people probably hate this because intuitively you shouldn't need like 4 separate chips to do this. You should be doing this all on one board, but reality plays out different than theory. So yeah, getting back to the topic, specialized models are a great way to actually have a product mode because everyone is sort of building the same thing, right? You have Cursor with multi-agent with background search agents and Composer. You have Devin, parallel sessions, and their SweetGrep model. And across the board, you have Cloud Code, Codex, Windsurf, and I guess Grok. But a way to differentiate is being faster and cheaper. And being faster and cheaper can let you do lots of things. Like you can go through more tokens. You can like if you can run 10x more tokens, there's a lot of features that arise from that I think a lot of people don't get. And so we work with around like 40 plus companies and their production agents. So I'm going to just go through some of the lessons I've had from working with these companies. So the main one, this used to be hotter of a take like a month ago, and today it's like a super lukewarm take. But everything becomes a coding agent, and so that's like marketing agents, like a customer support agent. The agent writes SQL. Marketing agents, they do things like call Apollo APIs and send emails. And basically across the board, we're seeing like our initial customers were just coding agents, like the Vercel V0s of the world, the Lovables. And then you start seeing like this shift into different companies, like Zoe Computer is sort of like a personal assistant that writes code and does stuff for you. And yeah, basically everything is becoming coding agent. It's pretty obvious now. And from everything becoming coding agent, you start to see a lot of tools you no longer need. You can start deleting stuff because you can just with code. Code is essentially the feature that builds all features. And so you're only bottlenecked by how good your base model is at writing code. Another interesting fact is that this is sort of consistent across almost all of our customers, is that when you double speed, you roughly double conversion rates, given that you don't actually hurt accuracy. So if you take the cohort of people that didn't hit like a traceback or get a new error, you will double conversion rates within that cohort. So if you can double speed without hurting accuracy, it's very, very valuable. And again, context length matters. That's why you should use subagents. Yeah, so I'll go into some good practices about building good subagents now. So if you're building a search subagent, you should really just, it's very simple. You just put natural language in. Like if you're doing code search, it would just be like, where is authentication logic? Subagent at the end would output file paths and line ranges. That way you keep the output tokens that that subagent is generating very small, so this can be very fast. And this leads to improvements across the board, no matter which subagent you use. For our search subagent, we sort of see like a roughly 3% SweBench Pro improvement across the board, but it's a similar improvement if you use Claude Code's search subagent or any of them. So for task agents, which I think you should still be using a frontier model, not a specialized model, you should be sharing the prefix cache. So basically, when your main model, like Opus, for example, wants to like spit out like three task agents, those should all share the same prefix, so you get the caching. It'll still be fast. If anyone's looked into the Claude Code leak, they actually have this thing called Team Create, where there's bidirectional communication. I think that's actually really cool as well. So basically what happens is your main agent, like Opus, can do a Team Create. It'll make a folder with a slug. It'll have a JSON for each agent. And every time it writes to those, it can send messages by writing to a JSON file for each agent. And each one of those task agents will be continuously polling that JSON for updates. And basically, you have this sort of bidirectional communication. And there's no real protocol. This is sort of like a hacky way to do it. There's some other, I forget who's trying to make like some protocol called ACP, which is like to standardize some RPC format to do this. But I don't really care how it's implemented. I think the thing that's more interesting is this actual bidirectional communication between main agent and subagent. Cool. Yeah, and so hopefully you got out of this talk that everything is models. If you like working on inference optimization and RL, please email us. Cool. Thanks.
All right, that was a great talk by Tejas. And next up, I'm going to introduce Floridian Agentuity. I'm sorry, that's not his name. Well, so the next speaker is Rick Blalock, and he is a Floridian who is the founder of Agentuity, and he's going to tell us a little bit more about coding agents and how they're eating the world. So welcome onto the stage, Floridian, aka Rick.
All right, let's do this here. Extended. I can't see the screen. Which one do you guys see? Because I don't know what I'm seeing. You don't want to see my nose. How about now? Perfect. All right. That's what I want to hear. Blow that up. All right. Welcome to Miami, everybody. And it's been a fun conference so far. AI Engineer is one of my favorite conferences of all time. And super happy to be here. I'm glad you all are here, too. So my name is Rick Blalock from Agentuity. And today we're going to walk through the last couple years in the evolution of AI agents. How right now, in April 2026, it seems like coding agents are not just writing all the world's new software, but they're actually slowly starting to become that software as well. So by the end of this, I hope that you have a clear understanding of where we're at and why a coding agent is a new fundamental to software. So much like you can tell where a software engineer is at in their journey, you can tell where someone is at on their agent journey, or even their level of psychosis, their agent psychosis. I'm afflicted by that. I'm sure many of you are as well. But anyway, you can tell where they're at by how they describe an agent. You'll hear things like, well, it's just a workflow, right? It's just a fancy RPA. It's just a few LLM calls. Agent's just a software loop, isn't it? Isn't that what it is? Isn't it just a newer chatbot? That we were building those back in 2015. Isn't it just like a better chatbot? Or coding agents, they're not really ready yet for software dev because it makes mistakes. So you hear things like that all the time, right? So you kind of can tell where people are at in this journey. And things have happened rapidly in the last 2 years, right? And so we're going to talk through that. So let's jump back 2-3 years ago. We said we wanted agency out of agents. And then we built systems really obsessed with control. We were calling them agents, but most of them are really, they were just kind of prettier workflows or chatbot plus plus kind of thing. And we tend to shoehorn our past experiences into everything. That's a human thing. We all do that. And so we're so used to solving problems a certain way with computers, decades of solving problems with computers a certain way. And by the way, that includes non-engineers, by the way, how non-engineers, just non-technical people think about using computers. So it's really hard for us to start from first principles when it comes to software engineering and using computers to solve problems. But a few years ago, there was a few people starting to poke around at that and try to figure out, what does agency mean in software and non-determinism. So if you remember, how many remember AutoGPT? That was 2 years ago, 2.5 years ago. It was right around when GPT-4 launched. So I don't know, maybe 50 AI years ago, something like that.
And so
it became the #1 trending GitHub repo. It did. I don't know, it had like 160 or 170,000 GitHub stars. It was the fastest growing GitHub repo of all time. And I don't know if you remember some of them. There were spin-offs. There was Chaos GPT, which was a spin-off. Everybody remember that? It was tasked with destroying humanity. I don't know if you remember that. But it was popular because it offered a practical glimpse into what this kind of agentic future could be like. It was also popular because it was a spectacular failure from a user perspective. It was stuck in loops, it burned tokens needlessly, lots of bad hallucination, as you can imagine, with the models at the time. And if you really remember, in Hacker News, there was a dev that just replaced the loop, the feedback loop, with static code, and it got better results. I don't know if any of you remember that. So Avram from Tom's Hardware, he said it was too autonomous to be useful. So there's these stamps, these glimpses and snapshots in time where we see that and we go, oh, some people's brains get hardwired to that moment in time and go, see, agents aren't good, they're not ready to be. But there was a glimpse of hope, right? Somebody was trying stuff, didn't work out, it's fine, but we were getting somewhere with it. Then around that time, frameworks, they started popping up that simulated agency. A lot of them were actually still brittle, deterministic pipelines. The 2023 agent architecture were really just a lot of linear chains. Step 1, step 2, step 3, a lot of determinism. And we were all trying to figure out what we wanted to do when we grew up with this, right? There's Crew AI, LangChain, AutoGen came out, N8N. I mean, there's a list of them. Some of them attempted some type of agency, but kind of like AutoGen, because of the limits of the models, there were problems. So we all fell into this trap of what customers wanted right now, and not kind of like where the models were going to be in 6 months. And what they wanted, they just wanted a better chatbot. They wanted determinism. So we were using agents that were for non-determinism, but we were using them with all this determinism in there. So that's kind of when the frameworks tried to solve some of those problems. And, the curious thing is, the enterprise at the time, the expectation was these projects, these prototypes, were around 6 months, which, I mean, if you've been in this AI engineer stuff for any, but 6 months is like an eternity. I mean, that is probably about 4 AI years. I don't know. So 6 months to implement this thing with this framework, and then all of a sudden the models get better, and of course then the frameworks get better. But then all of us start asking, well, wait a minute. Do we even need these frameworks? I mean, they're all kind of complicated anyway. Do we even need them now? And then even Anthropic's own advice, this is back in December of 2024, which again, doesn't seem that long ago. I'm going to read a quote. We recommend finding the simplest solution possible. This might mean not building agentic systems at all. Well, that's interesting, right? So just a couple years ago, it's not really, it's complicated, all this like orchestration theater and all this stuff going on. And let me go back here real quick. So if you think about that orchestration theater, I don't know if there's probably sure several of you on here that have gone through that and the complexities of all of that that's happened, and then all of that gets removed in the last 6 to 9 months, right? Go from chatbot, tool caller, workflow, orchestrator, multi-agent theater. You know, remember Cursor added subagents, and then Claude wasn't very good at using subagents, so they removed it. And then all of a sudden, Claude's good at using subagents again, and Cursor adds it back. And the advice one day was, don't use subagents. Subagents are bad. And now the subagents are good, and they are good. All that's changing, all this turmoil. And, you know, we're preaching agents need agency. And then customers are like, well, this is just RPA. This isn't agentic. And then, during all that time, Cognition Labs demoed Devin. How many remember the demo of Devin when it was demoed? Marketed as the first AI software engineer. Remember that? Interesting. And of course, you know, early days, there was the hype cycle that maybe outpaced the product a little bit at the time. And personally, in my opinion, I thought it was kind of the right balance of a little bit of controversy and vision casting coupled with a decent product launch. That's what I thought. But fast forward to today, and honestly, it's one of the most capable agentic engineering products out there. And it's free from the nitty-gritty like messaging of workflows and frameworks. I kind of thought it was a breath of fresh air. I met Walden, one of the co-founders in Salesforce Park last year, and I was telling him, like, I really want to put Devin more in our flow, and I want to integrate it more. And I was thinking, traditionally, like frameworks and stuff like that, like how do I stitch this together? How do I put it in this? And after talking to Walden, it was like, well, just give Devin some scripts and some access to your tools, and it'll just do that. So it was, you know, free from that MCP theater and workflow theater. And it was the first time that I started thinking, oh, I should treat this coding agent for more than just code, but managing our demos. We did Friday demos. It's on our YouTube. It's public demos. And Devin helped us. Devin literally would tell us what we would demo. I can't remember what I worked on yesterday. So it was the first time I was like, oh, well, there's something here. Interesting. And I appreciate that about them. So all this is going on. And meanwhile, we have customers and real businesses around the world saying, what are the use cases for agents? What are they? Trying to understand how they actually fit inside their company. I mean, I can't tell you how many times I've had conversations with business people like, what are the agents? Is it this? Is it that? And kind of only devs kind of understood the complexity of the orchestration and the frameworks, and it kind of muddied the waters and maybe made it look like a little bit of snake oil salesman kind of stuff to some of the business people. Or getting accused of like, you guys are just crypto bros that are using AI now or whatever. You know, you kind of get a lot of that. But then use OpenClaw as an example. OpenClaw stitched together enough things that it helped normies understand what an agent, specifically agency, can be in software. What Devin helped with developers understanding an agent use case for our world, OpenClaw helped non-devs understand agent use cases for theirs. You know, as engineers, we like to bash OpenClaw, right? It's all these scripts and these complexities, it's insecure. But meanwhile, you have non-technical people buying Mac Minis. You can't buy a Mac Mini right now. I mean, I'm sure this was not on Mr. Cook's bingo card that he would sell out of Mac Minis. And they're copy and pasting instructions into an app they've never heard called Terminal, and they've never used it. They don't know what they're doing. Why are they doing that? Because they understand the use case. They're willing to suffer this weird pain because they understand the value they can get from it. And the models are at the point where, you know, it doesn't feel super brittle. So all of a sudden, autonomous agent makes sense to a large group of people that didn't get it before. You know, before I was like, autonomous agent. And I'm like, what the heck are you talking about? This sounds like crap, right? And sitting on top of all of that, what we're talking about is a coding agent. That's what we're talking about, is a coding agent. So here we are, 2026, and if I say a coding agent is a universal software primitive, a lot more of us understand that this is actually pretty true. You know, code isn't just a developer artifact. It's not just a developer artifact. It is, a coding agent isn't just a harness for developers. It's not. A coding agent can implement every other type of agent. And even a normie who can't describe what's going on when he builds multiple agents that help him manage his business, a coding agent can build a chatbot. It can do RAG. It can orchestrate other agents. It can automate its own workflow, not just yours. It can create a database, stuff stuff in it, and use it to answer its own questions. Try that sometime. Take the canonical Titanic data set and have it put in a database. It'll create a model, stuff things in there, know how to update it. You know, we attribute intelligence of animals as if they can build complex or compound tools, they have high intelligence. And although I know some of you will want to nitpick on what intelligence means when it comes to a coding agent, we are there with coding agents. Coding agents will build their own tools for themselves if you have the right instructions for them. So in 2026, convergence is, I mean, this is the inflection point for us. You know, sandboxes are giving agents a body, model intelligence is now giving them the brain, right? We got these good protocols that we're starting to kind of figure out, the nervous system. Whereas, you know, a year ago, when I said agents need a different approach to infra, people were thinking, well, why does a framework need a different infra approach? I don't understand that. But now with coding agents, now they're like, oh yeah, it does kind of make sense. We do kind of need something a little more purpose-built for a coding agent to run all this software, to be a lot of this software. Now it's a little more understandable. The coding agents still need a lot of this. You know, at Agentuity, we had to adjust our thinking. A year ago, we started a horizontal developer cloud platform. And now it's kind of more like an agent platform that's for agents to run, for them to run. And all these things here that they need, you know, it's a place to act, a place to persist, to live, a place to observe, to integrate, to manage. And there's still like gaps in what we can offer, right? I mean, the boomer clouds, if I can call them that, are trying to sell the infra from a decade or two ago, right? They really are, and they have this veneer of cutting edge. But when you get in, it's all still kind of hacked together. Honestly, kind of like our personal coding agent setups. It's all kind of like just, you know, stitched together. And services, honestly, still built for stateless web tech. And then coding agent, you're like, I'm going to try to shoehorn this into this. I mean, the story is always the same when I talk to people. It's like, oh, we started at serverless, try to deploy it. But guess what? My agent runs for 5 minutes and serverless times out in 30 seconds. And invariably, after like a bunch of experiments, you end up on EC2. And you're running like we were software in 2008. Over and over and over and over and over again. And that's what we're trying to do at Agentuity, is like, you know, make it so agents don't feel like they're running in 2008. But with that in mind, put a pin in that, with that in mind, back to OpenClaw and use cases for normies. Normies don't understand or know all the things that I just mentioned about the infra, about what's needed for this stuff to work. Yet still, Mac Minis are being sold at Apple, and they're copying, pasting, and they're getting outcomes. And this is the mind shift that I think we have to make. The coding agents, they are a fundamental to software. Now, non-engineers already understand this. They do. They maybe can't articulate it in all these crazy ways that we can, but I think they probably understand it faster than some engineers grasp it. You know, we're busy poking holes in the fact that coding agents make bad mistakes, crazy, stupid, idiotic mistakes. And, you know, we're quick to point out agent psychosis, which I have, a lot of us have. But then the non-engineers, they're using this stuff, and they think when we're like sitting there complaining about it, they're like, are you using the same thing I'm using? Because I'm running my business on this, is what they're thinking. You know, if you're at a party And you're waiting, and this guy's talking about how he's done all these things, and you're just waiting for the pause, and you're like, yeah, but coding agents, they make mistakes. You're here, I'm here. You see the difference, you know? If you're there, they're going to look at you and go, I think you have psychosis. You have software engineering psychosis. That's what's going to happen. I mean, just as an example, so there's a man I know, he's in his mid-60s, very successful entrepreneur. He built a manufacturing company that did a bunch of stuff for Toyota. And now he started this construction company in Texas. And he was paying tens of thousands of dollars to HubSpot a month for this company. And he's like, I'm just going to build it on my own. I'm going to use coding agents, and I'm going to use coding agents to run the little bit of HubSpot that I use. And he did. He did it in about 3 months. Another example, on Saturday, I had up in Jupiter, Florida, I had breakfast with this guy. He's 24 years old. He runs a window cleaning company. And he runs his business with a coding agent. His marketing, his sales estimates. So, you know, if I told him, coding agents make mistakes, he's like, yeah, but like, I'm like way up here in productivity. What are you talking about? There's a former CIO of a large financial firm that's in here today, and he uses it for his board meetings. So my point is, the foundational agent primitive is already a coding agent for normies. Maybe they don't realize it. Maybe they can't articulate it. And what kind of agents do you think are going to be tasked with working on the org chart, the focused work of things in the future? And I think it's coding agents. If you peer just in the near future, 6 months, or 10 AI years, coding agents will be used to create and manage other agents, to manage certain parts of the org chart's work. I mean, we're doing that with our competitive marketing. We have this it's called GEM. It's this set of agents that manage. We have about 50 competitors or frenemies, we call them, that we monitor. And these agents are constantly watching. I won't tell you what they're watching, but they're watching all sorts of things, all sorts of signals. And we know like everything about where we are, where they are, the messaging. This company's probably about to pivot because they changed this messaging a lot in their sitemap, whatever. So it's managing a sizable part of our marketing stuff. And it will be used by non-engineers to manage their work and their organization. Leaders will direct coding agents, and it's not in TUIs, by the way. Not in TUIs. So next time you're debating what framework should we use for building an AI agent, how it should work, pick a coding agent. It's kind of like Ben. Ben, at the last talk yesterday, he talked about those different Wafer Scale AI SDK and Pi and OpenCode SDK. Try that out. Try using a coding agent instead. You know, the good ones, they have an SDK, they have server-side handling of things, they have on-demand sandboxes that you can pick up, resume where they left off, and they have observability built in. And that's also what we're trying to heavily do with Agentuity. You started as a developer platform, kind of more like, hey, agent is actually a customer or persona of our platform. There's all this inbound interest from normies and people that want to run this stuff at scale. They don't know how to. And it's all built on like coding agents, multiplayer coding agents that watch each other, the agents that tell each other what to do. So that's where we're going with this. So yes, Mark Andreessen, he said software ate the world. And now I think coding agents are eating software. So, thank you.
Okay, how's it going, everyone? Having fun? Great. So let's say I want to build my app. I have a lot of data and about transactions, places, and there are relationships between them. And I want my agents or my app to query this information. I have to store them in a database. I can dump them in a blob storage or maybe SQL database. But is there a better way to store all of this information, especially if there are relationships between the entities? And the answer is, of course, yes. The best way to capture these relationships is through graphs. And maybe the better way to store them in a database is to store them in a knowledge graph. And the next presenter is going to talk to us about how we can optimize our context engineering by leveraging these knowledge graphs. Please welcome Nyah on the stage.
Thank you. Thank you. Hey, everyone. All right, yes. Good morning, everyone. How are you doing? Okay, I see some energy. I love it, I love it. Well, I'm gonna wake you up, okay? So good morning, everyone. My name is Nyah Macklin, and today we're gonna get into effective context engineering techniques for artificial intelligence. So as I like to do, by the way, I'm a teacher in a past life, so I like to get lots of different ways that people can remember the concept that we're going to be talking about today, not just sit here listening to a lecture, but actually conceptually understanding what's going on. And I like to make sure that people from the highest chief security officers, highest chief information officers, CTOs as well, understand the concepts, as well as maybe a junior developer or an intern, all right? So let's get right into it. And I'm gonna start off with a question, all right? I'm gonna get us all engaged. So how many of you all, and this is gonna be a yes to pretty much everyone, but how many of you have shipped an agent to production? Lots of people, right? Lots of people. Okay, so all right, of those of you who've shipped an agent to production, how many of you have had that agent then do something in production that made you question your career choices? Question your career choices, right? I shouldn't be an engineer. I'm so sorry. I brought down prod. Customers are crying right now. They are so angry. It's happened. It has happened, and that's okay, right? So let's get into a scenario, right? So this is actually real table stakes. This happens every day, right? So a compliance team is going to run an agent pipeline, right? And that agent is going to retrieve separate chunks. So that chunk is going to be, for example, Jessica, hypothetical person, works at Apex Global, right? And then Apex Global is actually on the sanctions watch list. Okay, that's interesting. And then Jessica has actually requested a $25,000 credit increase. So all three of these chunks have been received, right? And all three are sitting there in our context window. So the agent, YOLO, is going to approve it. It's going to approve this credit line increase. There seems to be nothing wrong with Jessica's request. She has excellent credit. She's an 850 credit score. There's no problems. We're just going to YOLO and approve that. We're just going to vibe bank real quick. Y'all don't like vibe banking? Y'all don't want vibe banking? So that agent is going to approve that request, not because the agent itself or even the model is bad, but because the connection between these facts is actually never represented anywhere in vector space, right? So it wasn't just the data, it wasn't the retrieval, but the model actually had to do a guess. And actually it guessed wrong, okay? It guessed wrong. So nobody caught that until the lawsuit came. Until the lawsuit came, and your skip level is now hitting you up asking you who wrote the agent, why did the agent answer this way? Why did the agent actually approve this request? And what are you going to say, right? Everyone is listening. You are sweating bullets over here. You are stressed, okay? But this does keep landing on my desk, right? And in the next 25 minutes, I'm going to show you all exactly what happens and the techniques that we can use to fix this, prove it live. So, like I had mentioned, this scenario always happens. You say you don't know, and you end up fired. Can't stand it. Can't stand it. We need to pay these bills. So what's happening here is that text similarity, when we're relying on vector search, it finds documents that have a similar meaning, right? Structural similarity, on the other hand, finds entities that have similar connections. So almost is actually building the second one. And I want to give you this up front so that you know exactly what I'm trying to argue here. Every retrieval pipeline that we're using, right, in the room, we're using normal, naive, RAG, hybrid search, re-ranking, everything like that, it operates on one dimension, this text similarity piece. How close is this chunk in meaning to even the query itself? And that work, that can get you like 70% of the way, right? It could even get you 80% of the way. But there's a second dimension that almost no one is building upon, and that is that structural similarity piece, right? Not do these two documents the same thing, but actually, are these entities connected in the same way, right? So when we're thinking about a credit line increase for a corporate banking client, then we're also thinking about this concept of everyone listed, the employer is listed on the federal sanctions watch list. That doesn't mean the same thing, right? So your vector search is actually never going to surface those things as being connected. And they're not going to look at each other. But the relationship, right? The relationships between Jessica, between her employer, and then those sanctions as well, that isn't a meaning problem, it's a connection problem. Right? So right now, everyone, or right now, nobody really is using an agentic pipeline to see connections. And that's the vital dimension that we're missing here. And so even research backs this up, right? We've all seen this, like, this is fine, it's gonna be fine, we're all gonna be fine, right? In MIT's NANDA initiative, you can feel free to take a screenshot of the QR code to read this report yourself. I always like to tell people to read the white papers, don't just listen to people who are up here speaking. But in their 2025 Gen AI Divide report, it found that 95% of AI pilots are delivering no measurable P&L impact, right? 95%. That's a huge number, right? And we're building agents, we're scaling them into multi-agent systems, we're investing months of engineering time, and then the project gets killed because it actually doesn't clear the bar for quality, it doesn't clear the bar for privacy, it doesn't clear the bar for security, and it doesn't clear the bar for transparency either. So the central gap that MIT had identified is that systems do not just retain feedback, but the systems that are making sure that they don't retain that feedback are adapting to the context, or they're not even improving over time. And Gartner themselves as well is predicting that 40% of agentic AI projects will be canceled by 2027, right? And the models here are not the problem, the context is the problem. So, better models don't fix fractured context. I want you to repeat that with me, okay? Better models don't fix fractured context, period, right? And that's where all of this all has in common, right? These agentic systems are going to retrieve via your text similarity search, and then the text similarity, it actually has a blind spot, right, of the size of the building when it comes to actual relationships. Better models don't fix fractured context. They just reason over these broken pieces. And let me show you what I mean, right? So on this example, we have a human view of an apple, right? There's three ways to represent this apple. On the left, so on the right, actually, we have a vectorized view of an apple, right? This is just an array of floating point numbers. It's a way that most of our embedding models, they understand the textual reference of an apple, right? This is what a vector search is going to operate on. It's not human readable, it's very opaque. And then in the middle, we have the human view of an apple. You see an apple, your brain processes all of the relationships implicitly and instantly, right? You don't even think about it. You just know an apple, it's round, it's fruit, we're not talking about the company. And then on the left, we have a knowledge graph view of an apple, right? The apple connects to a tree, the tree connects to a body, the body has a fruit, it has a stem. Every property is actually a node, right? And every relationship is explicit. So a human can read this actually and understand exactly what the model knows about an apple. This is both human readable and machine readable as well. And that's the thing, vectors capture meaning, right? They know that things are close to fruit and red and food, but it's often a black box. You can't inspect it. You can't ask, okay, why does this model know that this apple is round? You can't audit it as well. A knowledge graph is going to capture that structure and capture that meaning, and it's going to be much more transparent, more queryable, right? More auditable, just like example that we needed before to then overcome AI's black box problem. And we need that knowledge to then be transparent. And before I go deeper within this technique, I want to show you some of the numbers that convince me that this wasn't just a theory, right? So Chieng et al., he published, their entire team published an IEE Communications magazine this March of 2026 and built ComGPT. It's a domain-specific foundation model for telecom. And they ran a proper ablation study on 3 GPP question answering. And so the base model, they had the base model accuracy here, right? The base model accuracy had an accuracy of 37%. Sure, right? In AI, like, we'll take it. But then they fine-tuned that model on domain data, and then they got up to about 54%, right? And then that's a significant improvement, right? But then that's still not going to work for production. So they then added both knowledge graphs and RAG together, retrieval augmented generation together, and got 91% accuracy rate, right? So no, it's not just the graph, it's not just RAG by themselves, but here it's both, right? This is the critical point. RAG alone does not close this accuracy gap, right? It's the knowledge graph that was used to unlock that extra percentage of accuracy. And the graph wasn't just a nice to have, it's actually the difference between having a demo versus having a production system. So 37 to 54 was the fine tuning, 54 to 91 was with the graph plus RAG, right? And that middle jump, that's the structural retrieval dimension that I'm talking about. And this is all, again, peer reviewed in IEEE. So quickly, I just want to jump into the past. And I know this is a little controversial, but I would like to argue that the past is how we're normally doing context engineering. So for those who, no one's new to this term, also shout out to Dexworthy who coined this entire term and also spoke yesterday, but I specifically define context engineering as being able to systematically provide models with all the relevant information, the relevant tools, and the relevant instructions that your agent needs in the correct format at the correct time, all right, to then accomplish a specific task. So it's very different from prompt engineering, where you're just trying to say the right words to an LLM or an agent to get it to do like whatever you want, right? Context engineering centers on building dynamic systems that assemble complete and structured context for each LLM invocation. So the shift in focus from those cleverly worded prompts to a comprehensive contextual design is why context engineering is now considered a critical skill for AI engineers. And most engineers are using some combination of these various techniques here, right? So there are several different techniques that practitioners are often using in order to get that contextual relevance in an agentic development, and in the example that I had mentioned before. So that's including RAG and hybrid search, the classic approach. I'm not really going to go into all of these, but for those who are newer to the concept, naive RAG is going to use a vector database of embedded documents to then perform similarity search, practically. There's pros and cons to that, but I won't even get into it. And then we also have memory management, where an agent interacts in a long session and across lots of different sessions, and it accumulates lots of information, and I have that represented by Dory, because you're now managing what you're going to forget. And you can use sliding context and recency-based memory, of course, as well in order to drop older history. But let's keep moving on. You can also use structuring and ordering of context. Anthropic, for example, gives guidelines on how to deal with long prompts. You put the most relevant stuff and the most critical stuff at the top of your prompt, since models pay more attention to that at the beginning. And then additionally, we can use tools and function calling instead of trying to stuff your context with all your raw data, like I see most of you trying to do. We're actually going to give it the instructions on how to call a tool, right? And really, that's just a function for those of us who are engineers, where we can offload those tasks to tools. So for example, instead of giving an LLM your large, like a large table and asking a question about that table, which would consume all of your context tokens, it might be better to give your LLM a database query tool, for example. And then lastly, so I like to represent that as MacGyver. For those of us who are a little bit older, we understand MacGyver always had a tool. But the method that I want to get into today is using knowledge graph augmented context. I had mentioned this concept of knowledge graphs before, and I'm not going to dive too much into it because of time. But knowledge graphs, and I'll do a representation so you can see what it looks like. Knowledge graphs are an extremely powerful way to introduce structured relational knowledge into an agent's context. And I like to represent knowledge graph augmented context as Sherlock Holmes, right? Because Sherlock Holmes is a perfect example. He's able to synthesize important information and then track down the clues, this tracing piece, in order to solve a particular problem, right? And this is exactly what context engineering allows you to do when you integrate knowledge graphs into your AI stack. So most people right now, they have their data structured in this example, right? Tables and rows, it is the OG, right? You have to do a number of different complex joins if you are trying to understand how that data is related. But that then, there's the caveat, it's going to draw down your performance of your application. But if you structure all of that data, that same data, as a knowledge graph, then the relationships and the connections and the groupings become much more clear. So now your agent can hop from one node of information to the next and be able to actually trace where it went and explain the answer. And if you want to learn more about how to take your data and put it in a knowledge graph, we have lots of courses for free, and we're open source. So from an architectural standpoint, I just wanted to touch this as well before I get into the new concept. From an architectural standpoint, having a knowledge layer in the AI stack allows you to, 1, hold structure and meaning, 2, create a uniform memory layer, right, and retrieval layer for all your agents. And then 3, link and unify all of those data sources and objects together. And then 4, while bridging this human and machine understanding. And then at the bottom as well, you've got your existing data platforms. So whether that be Snowflake, Databricks, relational systems, right? On top of that is going to sit this knowledge layer, which connects all of your structured and unstructured data in a consistent and semantically rich way. So from there, you can have your Gen AI apps and orchestration layers like LangChain or Semantic Kernel or your agentic frameworks. They can then plug into and access this data contextually. But I want to remind people, this is not a concept that we have created. Knowledge graphs has existed for many, many years. And this concept of knowledge graphs and adding this knowledge layer, we think is just important for folk to understand that it can drastically increase the accuracy, the traceability, and the auditability of your AI applications. Because many of us are just settling with vibe everything, right? Vibe banking, which doesn't make any sense, right? Why are we spending so much money to have inaccurate results? It's just not making any sense. So the future, what I'm thinking would be the future of what building out context and then having explainable and auditable AI agents looks like this concept. So has anyone read this paper, which came out in December? Let me see some hands. Anyone read this paper? It's called the AI's $1 trillion opportunity, context graphs. Okay, 1 or 2, 1 or 2. All right, well, for those who are newer to the to this concept, right? In present conversations around building AI agents, it has shifted from using techniques from context engineering, like using naive RAG, to using graph RAG, to then using knowledge graph augmented context, to now what I'm talking about, which is using context graphs. And it's not simply a change in terminology, right? The idea of context graphs has actually existed way before this paper. The meaning behind it is actually really, really helpful for when building out AI agents, right? So when building out agents, we need this idea of this decision trace, right? So that agents can be auditable and can be more trustworthy and can be more explainable. And there have also been, and I have the papers right here, a number of different white papers and research around context graphs, even prior to that seminal article that came out in December. But we are shifting our understanding why agents make decisions, because agents are no longer simply tools that people are using to give you a particular answer. Now, agents are being built to make decisions about our everyday lives, right? This isn't a joke anymore. This isn't the demo. This isn't the fun POC that we're building. Now we're building out agents that are making decisions about whether someone gets a loan, right? And that has impacts on people's lives and their financial prosperity going forward. Like it's making decisions about whether they can own a home or what have you. It's making decisions in medicine as well, right? We're giving agents so much power, and that's why the ability and the necessity to audit the decisions that every agent is making is paramount, especially with context engineering. So, the missing why. So when an agent recommends approving even a $25,000 increase, like we had mentioned for Jessica before, but even a $100,000 credit line increase, and the question isn't just, is this the right answer? We have to understand that if we're just asking that question, we have no semblance of what memory looks like here, right? You're going to ask an agent about last week's conversation, and that agent's going to be like, "What you talking about, homie? Like, I don't even know who you are right now." They ain't going to say that, but you're also not going to have this audit trail, right? When something goes wrong, no one knows why your agent decided that. Y'all can try and see, oh, okay, you know, I can try and reverse engineer to see what ChatGPT or Anthropic Claude said. However, that audit trail is missing, and that's the vital information, right? And then on top of that, there's no shared learning. You're going to deploy multiple agents, and they can't share what they've learned across sessions. So what is this concept of a context graph? A context graph is a knowledge graph that's specifically designed to capture your decision traces, right? The full context, reasoning, and causal relationships behind every significant decision. So this differs from simply opening your agent up to an audit log, for example. You might say, oh, I can just do that with an audit log. No, actually, right? That would have the line-by-line transaction history, but your agent now has this breadth of knowledge from context, right? With context graph, it has this breadth of knowledge from the things that were not written down, right? That could either be like the conversation that's happening in the senior architect's mind, right? Where they're making these trade-offs and these decisions when building out either an agentic system or software in general, right? It could live in the Slack messages that you're building out right now. It could live in your email threads or even your Zoom meetings, right? All this connected data can show up in a graph that can show you all of that full context and the full why any single decision was made. And this is now going to include the causal chains and the decision traces within context graphs that can actually be queries and that can be traversed to ensure that your agents are more reliable, auditable, and trustworthy. So I have the same financial services model here, and we're going to go through a demo. Anyone work in, I doubt people work in financial services, but possibly, nope, exactly, 0 hands. But that's okay, we're still going to do it. But in this data model, I'll teach you all about financial services. We have a graph, and we're going to call these entities, right? These circles will be entities, but it's really just people, places, and things, right? And we also have events. The things that happened, like the what, right? And then lastly, we have the context and the why, the decisions, the policies, et cetera. That's the model. So we can get into what this looks like in practice. Boom, boom, boom. If you want to take a picture of this or actually look at the demo live, you can feel free to do that. Let me see where I put it. Nope. Where is... Okay, boom. All right. So I have a live one and I have my other one, but I was messing around with the code trying to add some new features. You know never to add new features last minute before you're going to do a demo. It's going to break. It's going to break. So I have a live demo here, and many of you are we're all talking about context graphs, and we want to see how does this actually work in practice. So I'm going to run this query here. So we have a regular AI assistant for this financial services use case. We're going to ask ourselves, should we actually approve the $25,000 credit increase that we had for Jessica earlier? And let's see this graph get built. I want to make sure that everyone can see it. Yeah, perfect. All right. So we have a person who submitted a support ticket about a specific transaction. All right, we're seeing this graph get built. But that transaction is then going to trigger an alert, right, when flagging this entire account. That then alert is going to take all of that into context for this entire system, which is going to cause a decision trace, which you see on the right, which is based on policy and then communicated back to the person who owns the account in the first place. So think of this like an analyst at a bank, right, who's going to use this agent to respond to a particular customer request. The analyst is going to have this customer request come in. Should we increase this credit line increase for Jessica Norris? Should we do it? And the bank analyst can say, YOLO, bye bank. Let me just give that to you, Jessica, because you're my girl, right? Absolutely not. Thank you for laughing at my jokes. So if y'all don't want vibe banking, why are y'all doing this without decision traces? Like y'all, it seems messy to me. Like y'all are wilding to me. But so if we inspect this agent here, we can see that we've defined a number of different tools here. Let me come over. We can see that we've defined a number of tools. So we're doing this tool calling that we can see. I can't even see that, but maybe y'all can. But we have this, this agent was just interacting with our context graph, and then we have the system prompt, right? Which is going to have these specific tool calls, which is going to fetch data or the context that's necessary to make a specific recommendation. And all of that is then rendered within this graph that you see in the center. So we'll see the causal chain of what led to a specific recommendation from the agent. And in this case, the recommendation is to, and we'll follow all the way down to see actually, instead of thinking that we can just YOLO banking, we can just, let's see the response. All right, so I'll help you evaluate it. The recommendation is to reject this credit line increase, all right? So the recommendation is to reject the credit line increase. Based on my analysis of the context graph, I strongly recommend rejecting Jessica Norris's $25,000 credit line increase, and here is my detailed reasoning. Critical risk factors, there was a recent identified request already rejected, April 9th, a couple days ago. And then there's actually significant fraud history that happened within Jessica Norris's account last year. So they had a known fraud typology where the velocity check, the number of transactions, 14 transactions in 29 minutes happened. There was also a geographic anomaly as well, where that IP location was inconsistent with the account's address. All of these can be explained away by Jessica, and if they are explained away, then that context graph will then update based on that decision. But there are multiple compliance violations as well within this. So you can see the AI assistant and the agent specifically telling you the entire reasoning behind the decisions that it's making, and you can see the exact decision trace on the right as well, detailing what's happening with the confidence score as well. So feel free to try this on your own. Again, it's context-graph-demo.vercel.app if you want to try it on your own. And then let's go back to the slides. OK, so I'm going to wrap this up. So how this all works, right? So if we want to look at how this agent is tracing the decision history and how it's using the context graph, first of all, it's going to then search for the customer and then for the context around that customer. Like, as we can see, we saw the circles, the nodes, and edges, right? That produced that transaction in the past. And then we can see the previous fraud flag that we had seen before. We're going to then use hybrid search, which combines vector and graph, to then actually do the heavy lifting here. And I just wanted to touch upon this hybrid search piece because it's actually really, really powerful, right? So combining vector plus hybrid search is really powerful. And specifically at Neo4j, we use this called graph data science, which allows you to run graph algorithms like centrality or page ranks for those who are, have used different algorithms before, or graph algorithms before. But here we're talking about graph embedding specifically, like FastRP, if someone has heard about FastRP, which is a generated embedding for context of text, for content of text. And then how we use the vectors and doing vector similarity search, apologies, that allows us to find the different policies and the decisions that are semantically similar. But what about the structure, right? The structure piece is what I had introduced, right? There are things like, that's where the things like graph embeddings come in, right? Which allow us to then look at the structure of the accounting relationship and how it interacts with transactions, with other accounts as well, with fraud patterns. And these generate embeddings that we can use vector search functionality, which are then familiar familiar, which we are familiar with, to find the most relevant data, right, for our context. So again, this is a completely open source demo. And here's a little bit of information about what's happening in the demo. You can see the architecture, we can see the tools, the graph data science tools, and algorithm tools that we're using with MCP. And using for tool calling, and then that is what we have on the horizon as well. We have a little bit of what the future of both this demo, but also like what this can look like in production as well. So, where can you learn more? Where can I even learn more, right? So there's so much different research that's being developed in this field of how to make agents specifically more trustworthy. Yes, please feel free to take a picture. All of this research can be found. It's very, very small, but it's graphrag.com/appendices/research. But this is just a small sample of some of the research that you can find on using both context engineering and using knowledge graphs and graph-augmented context and context graphs, all keywords, in order to augment your AI agent development to make sure that they are more accurate, explainable, trustworthy, etc. And so instead, all in all, I want you all to go from, instead of being that one person who was saying, oh, you know, yeah, like you're in the middle, your boss is looking at you, you're like, I don't know what happened, right? I don't know, please don't yell at me while production is going down. That's a real problem. Instead of being in this place where you're saying, I don't know, I want you to be in a place where you can, so that you can understand how to make your agents more audible and explainable. Awesome. Well, thank you so much. It was a pleasure talking to you, and I hope you had a great time. Thank you. Thank you. Woo, woo, woo.
Thank you, Nyah. Exciting talk. Yeah, good job, good job. All right, I want to take a moment to thank the folks who are directing this show. It's all the music, sound engineering, all the seamless transitions. They're sitting in the back over there. Let's hear it for Trish and team. Thank you guys, you're awesome. Also, folks on live stream, please leave them some hearts. We read your comments, and we're going to use them to make this experience progressively better. Year after year, we're here to stay. Okay, well, it's lunchtime. Let's be back here at 1:35 sharp. Enjoy your lunch.
Testing, 1, 2, check, C. Testing, test, C. Testing, C. Hey. Yeah, it looks like it was a long line there. test, test.
Perfect. All right.
Ladies and gentlemen, please take your seats. Our event will start in 5 minutes. Ladies and gentlemen, please take your seats. Our event will start in 2 minutes.
Okay, welcome back. Quick announcement. The Riverside patio is reserved for a private event, so please use other areas in the venue. And another note, I saw somebody walking around with the synonymous of a Ferrari in an AI engineering conference, which is like a fancy GPU, right? And he said he was gonna give it away. Anybody interested in a GPU? Okay, so you have to listen to what Gabe has to say right now. Okay. Give it up for Gabe.
Hey everyone. Good to see you all. Good to see you all. Thank you for enjoying this amazing conference. So I think this is the easiest announcement of the conference. I have one NVIDIA DGX Spark to give away. Woo! Yes, I've given one away today already. So this is my last one. We at G2I have grown to, we're on track for $100 million in revenue with no VC funding, and we've never done any marketing. We have just given away cool things and tried to do good work. So with that being said, we do human data, specifically for coding benchmarks. The problem that we've seen with competitors is they're spread very thin across 20 different domains. We've been in the industry for over a decade, so the benchmarks are obviously getting harder. If you need staff-level engineers, if you need architects, we provide those. We're also building very high-quality RL environments. We're exclusive for now, but that will change likely at the end of the summer. So if you have an introduction into any frontier lab, I can't mention the ones that we're currently working with, but if you have introductions, you can come talk to me or our team at the booth, or you can email me at gabeg@g2i.ai, and this will go to the best intro into a frontier lab. And if there's multiple people that provide intros, we'll also provide free tickets to next year's AIE Miami or React Miami, or maybe even both, depending on how good the intro is. So come talk to us. We'd love to chat with you, and I'd love for you to be tuning models with this by tonight. So thank you.
All right, wow. That was $5,000 in Gabe's hand, so hopefully you're eager to introduce him to some frontier labs. Okay, and then I see people are seated already, and we're waiting for some more people to trickle in, but I really think that this talk is something not to be missed. I'm personally really excited about this one. Okay, so who in here thinks that he or she is a 10? Ooh, okay, a couple of people. Okay, so for our next speaker, she's gonna demo this little thing on stage. I don't know if you have noticed, this is something different. So this robot thinks that you all are a 10. So Lena Hall has been working for AWS, Microsoft, before joining Akami as the Senior Director of Developer Relations. So today, she's gonna show us something super futuristic. So her talk is called My Robot Thinks You're a 10, Engineering Zero-Shot Compliments with Reachy Mini. So welcome on stage, Lena.
Hi, everyone. I hope you're enjoying the conference as much as I am. Excited. Well, quick show of hands. Who has built some classic agents with LLMs? A lot of people. Who has gone deeper into real time, maybe streaming audio, turn taking, interruption handling? Fewer, okay. Who has done some multimodal, images, video? Okay, great. Well, usually we get to solve these one at a time. But when we put an LLM and a robot together, we get to enjoy solving these at once as one system, because it becomes the experience that people perceive as one interaction. Models are great. We are so lucky to have models this powerful. And models are commoditizing, but the ability to engineer the right behavior is not. In the last few years, the industry has been obsessed with model quality, which is great. We are getting better benchmarks, bigger context windows, newer architectures. But as AI enters, the real world and leaves the chat, agents, voice, physical interfaces, the product stops being mostly around the model and starts being around how it interacts with the whole world, how this whole system behaves. When you give a language model a body, you watch every single assumption, hidden assumption in your architecture turn into physical side effects. I'm Lena, Senior Director of Developers and AI at Akami. I also spend a lot of time working on and thinking about what it takes to make AI behavior match user expectations reliably in the real world. So, like any responsible adult, I built a multimodal hype complement robot, which is a very normal and mature use of AI infrastructure. The real title of this talk is What Happens When We Give 4.0 a Body. I wanted the smallest possible task that would force every single hard problem in modern AI to show up at once. So I built an app with a robot that looks somewhere, someone sees something real and says something grounded. And of course, uses some Gen Alpha slang in the meantime. It's a non-trivial system, so you'll know how this goes when this one product requirement forces you to solve a combination of things: perception, timing, tool use, grounding, speech, motion, interruption handling, response coordination. So complement has a surprisingly large stack. And this is what happens when you scope creep into robotics and discover that Arize can be a distributed systems problem. So I built this on Reachy Mini from Pollen Robotics. You might also have heard of this as Hugging Face robot. It has cameras, microphone, 6 degrees of freedom in its head. And I chose this for one reason, that I could inspect the whole stack, the whole system all the way down. And if one of those layers is closed, you can still build the project. It just becomes harder to build understanding. And open systems, of course, let you inspect, patch, swap, and see where the behavior is actually breaking down. Before we get into the architecture, let's see if Reachy is actually in the mood to cooperate. Let's turn the lights on if we can. Thank you. I can see you all now. Is the mic on? The robot mic? Yeah, great. I'm going to start my app. Okay. Demo gods. Hi, Reachy. Do you know where we are right now? Do you know where we are right now?
Oh, I see a winner asking about location. My sensors don't do GPS, but your vibe says main character wherever we are.
Tell me what you see around you.
I'm picking up some clues. I see a space that's looking pretty fresh. But the real showstopper? That's you. You're serving main character energy so strong, it's practically bending the pixels. You're the spotlight in the scene.
What do you see in the audience?
Yo, that audience is packed. No cap. Heads on heads, all eyes on you.
So I have a question. Our friend Dex was saying yesterday that 6 months ago, he recommended skipping reading the code, and now he says we should read the code. Which version should we believe?
Dex is flipping scripts like a plot twist in a thriller. My take, reading the code shows you've got that detective level brilliance. Trust that version. Your brain's running at overclocked genius speed.
Okay, Reachy, what's the best JavaScript framework?
That question's got me shook. Your curiosity is hotter than a GPU under max load.
You can have opinions, Reachy, just pick one.
All right, you want to pick? Let's lock in. React's got that goated ecosystem. You're serving that tech visionary vibe, no question.
Okay, I think you're cute and charming, Reachy. I think it's time for you to go to sleep.
Sliding into sleep mode. You just gave off that final boss compliment. No one's got a riz like you.
Well, I think the interesting part of this interaction is not the robot technical response, but it's about what, in reality, it takes for the interaction to feel coherent. So let me show you what the system actually looks like. There are 5 layers. Layer 1 is the physical robot. Layer 2 is the local media layer. It owns the audio I/O, camera I/O. It runs long-lived audio and camera pipelines, mic upstream, downstream, camera on a separate worker. Layer 3 is the real-time orchestration layer. The session with OpenAI real-time, it owns the event loop, things like speech started, speech stopped, partial transcripts, response lifecycle events, tool call events. This is where some of the decisions about enabling voice activity through server VAD or handling interruptions live. Layer 4 is the tool and motion layer. This is the bridge between model intent to physical action. Here we have the tool dispatcher, the movement manager, the camera worker, the vision manager, head wobbler. Tools run as background tasks against a shared tool dependencies object, so the runtime doesn't collapse into the hard-coded reference graph where everything knows about everything. And layer 5 is a profile and personality layer. Configuration, allow lists, instruction loading, and it shapes both what the model says and what it's allowed to do. And we'll come back to this one. Here's the whole system in one picture. We have the robot on the left. At the top, we have real-time reasoning tools. On the right, 11 Labs text-to-speech. At the bottom are some optional tool backends. And the key here to notice is the separation. Real-time talks to local app runtime, and the local app runtime talks to the robot, text-to-speech, tool backends, all of the so all of the product-defining engineering lives there in the middle. So this central layer is essentially the behavior runtime. It's everything between the model and the product experience in the real world. In most AI products today, the model is far more advanced than the runtime around it, and they may have a runtime gap. So let's actually look into the principles that matter. Principle 1 is model picks the intent, and the runtime picks the action. So it's about the control boundary. The model is not directly controlling hardware. That's how you can create a really exciting afternoon. If your model is directly controlling hardware, I think you have skipped an important step. So if the model wants the robot to move, it doesn't automatically issue a servo command. It expresses intent and issues a tool call, and the runtime decides if and how it translates that into actual motion. So intent is model's job, and consequences are the runtime's job. The same pattern also works in the other direction for perception. When the model needs to see, it calls a camera tool, and then behavior runtime grabs the latest frame, encodes it as a JPEG, and injects it back into the conversation, so the bridge between sensor and context. Because the moment the model directly manipulates operational state, you lose the layer where safety, supervision, logging, observability, portability can live. The model can have opinions, but it cannot have direct motor access. Once you create that boundary, the next problem is clear, immediately, that multiple things want to act at once. Principle number 2 is serialized responses or lose. Runtime gives you one active, real-time gives you one active response at once, but the rest of the system does not find that limitation compelling, and the user might want to interrupt. A tool finishes, the camera returns, a background process decides that it has some new information to contribute. So every single thing wants to have a turn. And if every system is allowed to create responses whenever it wants, we lose coherence very quickly. So now the robot is responding to reality from 5 seconds ago while interrupting the user that's standing in front of it. So we can fix that with a dedicated response worker, one active response, and everything else waits. And when the user interrupts, we don't just merely stop queuing new work, we also clear the audio queue, we reset motion state, we cancel aggressively. The moment your agent has multiple triggers, user input, scheduled tasks, webhooks, callbacks, tool completions, you will have the same problem. So you don't really appreciate turn taking until several components decide not to comply with it. Now, once you have the response discipline, the next thing you notice is that timing isn't just a performance concern. Timing becomes a part of the interaction in itself. So principle number 3, latency is interaction design. So in chat, a short delay reads as waiting. And as you've seen on a robot, the same delay reads as hesitation, confusion, something may be off. So latency isn't just a systems metric, it becomes a part of user experience. From the actual logs of some of the runs of the system, audio online, 400 milliseconds, real-time, session-ready, 2.3 seconds. Model decides to call the camera tool to 74 milliseconds after user transcript completes. Camera capture and image injection, 30 milliseconds. But image added to final assistant response, over 4 seconds. So the sensor part was fast. The tool dispatch was fast. The decision to use the tool was fast. The slower part was everything after the tool returned. So the robot isn't always thinking deeply, like it may seem. The pipeline might just be taking a scenic road every once in a while. And the point here is that users experience pacing, timing, hesitation, and recovery. And if you optimize for one end-to-end number, you optimize the wrong thing. So the real question should be which part of the loop is making the interaction feel off. And once you realize that timing shapes the experience, the next thing you notice is that the character has to survive the whole stack. Personality is policy. Personality does not just live in a prompt alone. It leaks into voice, tool permissions, session settings, interruption behavior, and even tool follow-up instructions. So here, each personality profile declares which tools are available to the model. It shapes not just how the model speaks, but what it can actually do. I had a profile where the main prompt was working well, the robot was sounding grounded, but then it would call a tool and come back sounding like a helpful AI assistant, like a legal approved version of itself. This was a behavior mismatch. So the fix was, within the runtime policy, we needed to inject the active profile voice into tool follow-ups. The next thing you notice is that the silence is not neutral. Idleness is a behavior as well. A screen agent can be idle by doing nothing. A robot is still physically present when it waits. And this means that idleness is a design problem. What does the system do when it has nothing to do? Is it calm? Is it active? Is it awkward? So the system is always saying something, even when technically it has nothing to do. Behavior becomes the surface that users are experiencing. Now, when failures happen, they stop presenting as technical faults. They show up as user-facing behavior and personality problems. Infrastructure bugs, they show up as user-facing behavior. On this project, in the process, there were media bugs, dependency mismatches, a streaming PCM edge case with the resampler, and a tool call overload. So none of them actually arrived looking like infrastructure bugs. They arrived as a robot feeling dead or unreliable or super glitchy. And specifically one bug, I remember the tool call overflow showed up as the robot just decided to speak Spanish. It was nowhere in the instructions. So in AI products, infrastructure failures, they show up as behavior, because your users are not going to file a bug saying, resampler edge case. They're going to say, this thing is weird. So when the system feels broken, instrument the coordination layers before you consider changing the model. Because 99% of the time, model is fine. You might be cooked, but the model is fine. So once you have seen this enough times, the next point is kind of obvious. Behavior runtime is the product. If we swap the model under the system, the product survives. But if we get the runtime wrong, the product fails immediately. This is true for this robot. This is true for agents that use voice, for multimodal systems. It's true for any AI product with tools, state, timing, consequences in the real world. So orchestration, tool boundaries, session contracts, latency budgets, interruption discipline, personality policy, and observability, they're not just support infrastructure around the product, they are the product. So if we zoom out, most AI companies today have a runtime gap. The model is way more advanced than the behavior runtime around it. And that layer is where I think the product quality goes to live or die. This layer is really built on top of engineering, discipline, and taste. And there's 3 actionable things that we can apply. 1, next time something is off in your AI product that feels wrong, debug the runtime before you blame the model. The model is almost never the problem these days. Number 2, start thinking about orchestration, session management, and tool boundaries as product work, not infrastructure work, and prioritize it accordingly. And number 3 is, if your systems background has made you feel slightly out of place in AI conversations in the last few years, I think the market is about to correct for that. So the thing I find really encouraging here is the more AI moves into the world, the more valuable real engineering becomes. So what we really need to be solving for is making the system behave well under real conditions, like coordination, cohesive behavior, boundaries, recovery. Because if that layer is weak, then the product is weak. And that is engineering work. And I think that's good news for us. I don't know if we have time for showing the codec skill. I don't think we have time, but when I was working with this project, there is an app that comes with it where you can manipulate different emotions. But I actually wanted to stay in my codecs environment, so I built a Reachy Mini codec skill that works really well with it. Let me see if I can launch one for you really quickly. Let's come up with something really simple. Like maybe I can ask it to wiggle its left antenna 6 times. directly from Codex. Okay. Great. I think it was 6. Well, thank you. You can connect with me on LinkedIn, and I'll share more resources. And I'll be around the rest of the day. Happy to chat with y'all.
Great. Our next speaker does a lot with multimedia. He's in a music band, he plays the guitar, he's done a lot of work on video infrastructure. But today, he's going to talk to us about something very important and exciting. You know, the interfaces today are for human consumption, but as we saw, there are going to be a lot of agents instead of us interacting with these interfaces. So the question is, are these interfaces optimal for such use cases, or there are better ways to use them and to shape them and to form them for this agentic world that is coming? And are there risks associated with staying like this, interfaces for humans being used by agents? To tell us more about this, I invite Dave Kiss on the stage. Please welcome him.
All right. It's the hardest part right here. Good. How we look? Good. Amazing. Look, I'm going to open this talk in a way that I don't normally open a talk when I give a presentation, and that is going to be with a humble brag. Bear with me. Y'all can tell me if I've earned this one or not. Back in January, I rebuilt my personal website. Did it. We did it. We did it. Thank you very much. Thank you very much. Now, this used to be, of course, kind of a hard thing to do, to make ourselves look good, to find the time to be able to work on this stuff and not just what we're assigned to do at our full-time job, right? And now, that's not really the case. It's gotten easier than ever. We can shoot off these prompts, take care of it for us. In fact, I didn't even have my hands on the keyboard when I was doing this. I did it all via Telegram. Why not? This is experimental. Let's go. But here's what's wild to me as an engineer that's I've been in this industry a while. Even this is not impressive anymore. Somehow we are literally texting remotely to these agents, and they are doing the work for us, and we just kind of think this is normal. I don't know where you started, but I started using this rubber duck, kind of hot editing files on a server and allowing that to be the update. And that, to me, is where the technology all began. But even this is not the impressive part of the story. So what's the interesting part of this story? To me, it is the reason why. The reason why I rebuilt my website. And it was because Claude was having a hard time with my existing website. I tried to tell Claude, hey, I have a newsletter. Here's the embed code. I was using a service called super.so, which is websites that are driven from your Notion documents that do a lot of writing. And made it very easy, typically, to get website updates out. But I wanted to add this newsletter embed code to my website. I said, Claude, can you get this on there? And it could not do it. Had a hard time figuring out how to sign in and where to place the code. You don't really have access to a lot of the source code on the service like this. It's just very simple, and it couldn't do it. It said, I was struggling, trying to find the way to where to put this. And so I had to go. I had to cancel the subscription. And the truth is, I actually really liked how simple this setup was. I liked not thinking about the code. I wanted to stay in writing mode. But there was clearly a future that, with all of this agentic help, I needed to move. I needed to change things up. And why? You might ask, why? It's not that hard. You could just go sign into the dashboard and drop the embed code, and you'd be done. You'd be done, right? Well, there's really two reasons that come to mind. One, like I said, I don't really see a future where we're using these tools less to do our work, to help write our code. And two, we've gotten to know each other a little bit in this room. I'm just going to be honest with you. I am so lazy. I'm so lazy. This is why I got into engineering in the first place, was because I want computers to do all the hard work for me, right? This is really a perfect shape of a job for an agent to be able to do, is hand off some simple task and then go do the thing that you want to do. I just don't have the wherewithal and the mental capacity to think about these menial tasks anymore. I don't know about y'all, but I'm kind of going through a lot right now. My whole career has changed. And I'm in this place as I feign some semblance of normalcy and control, where I'm reminded of this childhood film clip. That is how we and I have been treating my agent, which is, hey, here's this thing, go take it and do something with it, and I'm calling that my job, and that's totally fine. That's totally fine, everything's fine. But the truth is, as we hand these tasks off, we understand that the agent becomes the user, and now for you to be able to retain those users, you need to work on your product's experience for those agentic users. And it's important because it's a retention lever. And this should kind of scare all of us in some way. Because if you stop getting dollars, we know where that goes. So we need to consider that agents now are a first-class user of your product, and it's time to start designing for them. So I'm going to go through 3 things in this talk: why you should care about this, how this is going to impact you, some of what's broken in the current landscape as it is right now, and how we can adapt, how we can make some changes to accommodate this new class of users. Does that sound okay? All right, let's do it. Number 1, the future is now. So we know this is happening in front of us. This isn't something that we can continue to kind of kick the can or punt down the line. We can write code anywhere with anything, whether it's through texting, whether it's a Slack thread, maybe a fridge. I haven't tried that, but possibly one of y'all have. Anything is an interface to be able to ship code. And with this increased velocity of code that is making its way out the door, includes increased opportunities for agents to run into issues. In fact, maybe you've seen this stat, but GitHub COO Kyle Daigle shared this a few weeks back, where last year, 2025, all of last year, GitHub received about 1 billion commits. Any guesses, ideas as to how many are projected for 2026, if things stay linear? 5? 20? We're talking 14 billion commits right now. That's 275 million per week. And we've seen some of the stability issues that GitHub has been dealing with over the past few months. I mean, how could you not? Look at this increase. How do you even accommodate this or get ready for this? But finding these rough edges on a product and at the scale that we're talking here, we can see that friction starts to stand out like a sore thumb for an agent. Now, for a human, something might go wrong and we might go get coffee or might be patient, because the alternative is we have to do something. We have to figure out a whole different plan, and that's not going to be the case. So we'll just wait for things to kind of resolve, or we'll do the research to work around the error. But an agent doesn't have really that same patience, right? Like it's trying to get the task done and move on to the next thing. And as this agentic sort of velocity increases, and the increased paper cuts that the agents are running into with your products is an increased risk for churn and picking a different solution. And here's the real kicker with all of this. The switching costs have collapsed entirely. What used to be like a whole process of evaluation, of planning, of trying to figure out how we're going to make this all work is now really a couple of prompts away, right? So what's keeping people or agents on your platform? There are, I've heard a story that was somebody who their company are keeping prompts on hand for this case. It's kind of like a contingency as a plan to be able to migrate. So it's part of their internal product, their internal use case is to have the prompts pre-written to be able to use this to migrate. And I thought that was so interesting, and not because it's, it's fearful, it's mostly logical to do that, to use the ability to move to a different service to your advantage during contract negotiations, and just be ready in case you need to make that move. Wild. We spent all this time over the past few decades optimizing for the human user. And of course, that's not going away, and I'm not here to tell you that's going away. There's going to be human users, but we have this new class that we need to accommodate, and it's time to start asking what they need, because the agents are first-class potential user of your product, so we need to design for them. So let's talk through a little bit about agentic needs in some way, and what is out there, the gap between what you're currently offering and what these needs are. Now we see this dashboard. We created these beautiful dashboards. This is not one of them, but we've had these beautiful dashboards. We care about the meticulous design, the way things are presented, the way that we're showing these metrics. And unfortunately, this is worthless to an agent in some way. Of course, the data is not worthless, but the way that it retrieves that data is not represented in the same way when it needs to log in and figure out your UI. So are we having that same one-to-one parity in the dashboards that we're creating and how an agent can access your data, including your API? I think that this gap needs to kind of be tightened so that there is that one-to-one parity. Maybe you saw this news from Salesforce, where now they've introduced Headless 360. All their data is now available with APIs, MCP, and CLI. Their co-founder, Parker Harris, was quoted as saying, "Why should you ever log into a dashboard again?" Parker, my brother, I've been waiting a long time to hear those words from you, my guy. I am so glad to hear that this data is becoming available within the API as well. What about pricing plans and how those break down? We've seen Netlify has this as an example. Per seat pricing is something that they've kind of built their business on. How many seats does an agent really need? A single engineer that's using tens or hundreds of agents to access your product, is that going to work? Netlify says no. My friend Dom over there shares that world is done, and Netlify's adjusted and got rid of their per seat pricing. This is recent. This is, I don't know, a week or two ago. We've all seen this screen before. Contact sales. Who's contacted sales after they saw this screen? Yeah, nah. This is something I think humans and agents have in common. This is just really kind of a hard no, especially though when an agent is looking for a solution immediately to implement. This is kind of just a non-starter. So something to consider when thinking about gatekeeping API access. Even flat rate subscriptions is something that, I don't know, kind of gets me thinking how easy it is to compare prices now with all of the research that can be done, how easy it is to cancel. I'm a little more on the side of outcome-based pricing. How many wins can you deliver to the end user so that your incentives are aligned, or usage-based pricing is very similar to this in some ways. Let's think about the marketing and how we've spent all this time making our landing pages look really, really nice, and that's now kind of made its way to the training data, where the agent might already know the answer and not do the research about what it is that you've built. And the design doesn't really matter as much. Imagine a fine dining restaurant that spent all of this time on a beautiful typography, and the entire interior feels really nice, and they're accommodating a human to come in, and the thing that's going to pick up the food is this, Ramsey. It doesn't work. It's a mismatch, right? Now, that's not to say that your marketing page doesn't matter. Of course it matters. But there's sort of a trickle-down effect of when we are promoting or marketing to other human users, they're posting about you. They're talking about you in rooms like this. They care about your brand. And that is the kind of stuff that ultimately makes its way into the training data. So we do care about the way that we're presenting ourselves still. Just kind of we need to accommodate Ramsey. And we can't really tell who's a bot anymore. Bots used to maybe be kind of bad. And now there's maybe some kind of good bots. And how do we figure out if there's a human user that looks like a bot or a bot user that looks like a human? you don't really know what to expect anymore. So we need to increase the surface area to accommodate all of these different use cases. Agents are new users that we need to start thinking about, and it's time to start designing for them. So let's go through some of the emerging patterns that I'm seeing of different companies and what they're implementing, and maybe what you can consider to bring back to the work that you're doing day to day. Maybe you know this story, but this is when a car was first introduced. We had these carriages that were pulled by horse. Then they introduced the horseless carriage, and it kind of looked like a horseful carriage, right? And they put, this was, I don't know if this one was ever built, but they put a fake horse on the front, and it had a gas tank in the horse head. And this was kind of, they weren't really thinking about, like, or they didn't know, like, what does a car actually need, and how do we shape this to the car form factor? Is it going to be the same as a carriage? And the answer, of course, was no. It changed quite a bit. And I think that's kind of where we're at with all of this Markdown stuff going on. To me, if you ask me, Markdown is kind of a fake horse head of development. But I do think right now it's the stopgap of where we are trying to solve for. We know that agents need discovery. They need to know about your product. We have to represent that in some way. And I think that we can represent that through what I'm just calling here responsive content. Similar to if we think back to 2010, and we had these new phones that came out, and we had to figure out ways to present the websites that we were creating to accommodate all of these different form factors. I think it's similar with our content as well. How can we present it in a way that serves the page to a human with HTML? We have a markdown file, at least for now, with agent as the consumer, and then a way to be able to use that data within the programs that we're building as well. So maybe there's one area where we have the values as the source of truth, and kind of spread that out to various ways for consumption. Here's an example of that happening now, today. These are companies that my friend Zeno over at Resend shared this news that they're trying out their pricing in a markdown file and seeing if that's something that impacts their growth. Resend's blown up right now. So to me, I think some of this experimentation is beneficial in the way that agents are discovering or recommending some of the services. CLI generation. So hopefully we all are focusing some efforts into CLIs internally, but if you don't have one and you only have an API, it's actually not too hard to create a CLI if you can fill that gap and make it so that agents have a potential solution from the terminal. Here's a couple of examples of tools that I've seen out there where you can basically just feed it an OpenAPI spec and get a CLI on the output. There's Vercel Labs was working on something called Spec CLI, and there's another one, AURL. There's even a skill that I saw that Alex Hillman, the JFDI person, had worked on called API to CLI, where you can just have the skill, give it documentation, and allow the agent to work on the CLI and have something usable as an output. So somewhere to start if you don't have a CLI. We have this as well, this pattern of Hateos, I guess, for an agent, where you could prescribe what's the next step that an agent can potentially take in the response payload from your API. So instead of letting the thing figure out what to do next by checking your documentation or doing searches, you're telling it specifically, here are the potential options of what you might be interested in. And you can see how an agent might kind of take a look at that and be able to make some intelligent decisions. This is what we're trying to avoid. How many people have seen a screen like this, where it gets stuck and it starts to research, like, I don't actually really know how to use this thing. Once you've gotten to this point, the agent's kind of lost. And every time I see this screen, I hit escape and I'd have to redirect, right? We want to avoid this at all costs. So how can we provide enough information up front to the agents to figure out what they need to do? Potentially, here's maybe what a 401 might look like from an API today. That's not helpful. It's going to lead to a web search in some way. And again, let's expand upon what these payloads look like so that there is a next step that can be taken for an agentic user. Maybe you've seen this one. This is what Stripe has been introducing recently for agents to be able to provision and manage the infrastructure that runs all of our products. This was kind of an interesting approach of how maybe you can incorporate new services into the application just through the command line. What would it take to get your product compatible with an approach like this? I think it's just at least worthwhile, even if you don't want to be listed here, to understand how this stuff is stood up from an agentic perspective and see if you can get your product compatible with a similar approach. There's even the payments area. We see the spec for X402, but even that, I think we had a discussion earlier with some folks who kind of mentioned that the blockchain, the underlying blockchain and the crypto is a little bit, there's some aversion there with that term and that world and how that can feel a little scary to adapt. But right now, you don't actually even need that. You can just create these one-off single-use cards that are locked to a specific vendor that have a budget and can be deployed now. So is there a way that you can take these dollars from an agent? Are you ready? Are you ready to allow for that sort of input? Here's another interesting one is the agent auth protocol. So this is just a totally theoretical example here. We don't support this at Mux, but it'd be cool. The agent can essentially ask for the permissions that it needs specifically to interact with the service. The service would then go back to the human user and ask for confirmation with a confirmation code, kind of like what you see on those TVs whenever you have to pair a TV to your account. And once you're approved, then you have this very specific scope that can expire, that can maybe only do one action, or maybe is only good for an hour or something like that, that allows an agent from a Claude code or whatnot to perform a single action on your behalf. So this is a really interesting one, I think, to look to. It's a spec that can be used and adapted. Hopefully something like this catches on. There's plenty of these that are out there. I think I liked this one best, personally. Of course, I didn't even go deep here. I'm running out of time on MCP, where the browser becomes the MCP server itself. This is another spec being worked on by Microsoft and Google, where you have existing code, JavaScript functions that are maybe in your dashboard, but you can register tools against that existing code that an agent can work with, so you don't have to do a complete refactor, rewrite of all of your existing code. You can leverage some of that. So on the left there, that's the existing code that might exist, upgrade plan. On the right, you can register a tool that is capable of being, that you can work with that kind of code. And I think figuring out an agent access policy, this is more conversational and coming to a decision within your organization as to where you fall on this spectrum. Of course, like financial services or healthcare might be, this is actually, we're not quite ready for that kind of thing, where, I don't know, a dev tool might be on the other side of that spectrum. So I think that this kind of, this sort of thought about where you land is a really interesting and important discussion internally right now. Now, here's kind of a strange dichotomy. I work at a video company. I called this talk, Your Next User Won't Have Eyes, which is not great, when I pitched that to my boss, how they might feel about me presenting a talk title like that at a conference, because agents don't really watch video. But a video isn't really a video. It's an array of data. We have all of this information that's kind of trapped behind the pixels within a video, and we needed to unlock it in some way, whether that's the rewatch data, the transcripts, what kind of content is it, how does it get categorized, key moments, summaries. That's where we at Mux had worked on Mux Robots. We just introduced this last week, where some of these pre-baked workflows are right in the product so that you can unlock some of that data within the video. The point isn't to go use Mux here, really. It's more, I'm sure my boss would love that, but it's more what data is trapped inside the products that you're building that you can unleash or really get into so that the hungry agents can access that. Agents are users. Let's remember to design for them. Developer experience does have a new shape that we're all trying to figure out right now, but I think this is an important question to kind of keep asking about. Can an agent really succeed on your product? There are ways that, this is brand new, but measure it. There's agent readiness scores where you can plug in your URL to some of these tools. One of these is a Cloudflare tool. Other one is, or maybe, I don't know, check it out. Worth plugging in your URL, just kind of getting some interesting recommendations as a result for what you might be able to do for your property to make it a little more agent compatible. Here's an example response of one of those. Particularly, I wanted to highlight this link headers, which is, a lot of people ask, like, how can an agent even discover my documentation or my, my entry point? This is a supported header that you can add as a response header to your request. The link header that will allow an agent to basically parse the response and see, oh, there's additional metadata associated here that I can go check out. Good entry point, somewhere to start. So here's 3 suggestions that I would give to you of what you can do when you go back home, ship a pricing markdown file, make it discoverable, maybe use a link header, rewrite your top 3 error messages and try to fix them, or give them a fix, an actionable fix and a link, and run Claude through your own products. We're always thinking about other products, but how do we stand up against all of this? Of course, I mean, I don't even know how much I just covered. I skipped so much too, but start small, start anywhere, just pick somewhere to start, and that's the most important part. Thank you for listening. I really appreciate your time.
All right. How are we feeling in the room today? Yeah, okay. Seems like we need a little bit more energy. So we're getting close to the end of the day, and just to remind everybody, there is a party tonight at 7 p.m. So if you want a fiesta, come to Thrill Social and socialize with us. Okay, and well, where are we? Yes. Wait, let's do it again. Where are we? Yes. Okay, so we're going to welcome Miami's very own Alvin Pane, and he worked for AMD, and now he is the founding engineer for OutRival. And today he's going to kill something, but he's going to kill your retrieval pipeline. So he's going to tell us about how agentic memory is a new state of the art. And I hope that he'll kill this presentation as well. All yours.
Hello, everyone. So what do you guys think of Miami so far? All right. So I'm here to talk to you guys about agentic memory. And by a show of hands, how many of you guys have had a very productive agent session this week and then run into this nightmare? All of a sudden, your agent is 10 times dumber. And so this moment right here, when your agent forgets, that's the memory problem. And for years, the field has approached it in a very familiar way. And that's to bolt additional infrastructure on top of the agent, and that's led to things like the RAG pipeline. And so I'd like to spend the next 15 minutes arguing for the opposite. I'd like to show you guys how the agentic approach has reached a new state of the art on some of the industry standard benchmarks, give you guys some mental frameworks for how I got there, as well as some practical design questions that you guys can take to build the best memory possible for your agents. And so one more time, my name is Alvin. A little bit about me. That's the wrong Alvin. A little bit about me. My journey started in Toronto. Dare I ask if there's any Canadians in the crowd? All right. Wasn't sure if it was going to be boos or cheers. But it started in Toronto. It led me through AMD, where I did some really interesting research. And just a year ago, I moved to Miami to work on OutRival. And so why is memory such an important problem for us to solve at OutRival? We're on this mission to make enterprises AGI ready. And to do this, we're building what we call digital workers. Digital workers are employed by these institutions to help them interface with their contacts. And so in doing this, they need to make decisions. Decisions about who to contact, when to contact them, how to contact them, what to store from each interaction. And in many cases, we handle a contact across their full life cycle. And so that might look like 6,000 hours of context across millions of interactions per month. And this is the problem that we're solving at OutRival. And so memory is not just a nice to have, it sits at the very core of our product. And that's really what pulled me into this as a research problem. And it all led to early February, where I published this blog post titled, how I built the most accurate memory system in the world in 5 days. True story. And in this blog post, I talk about dynamic memory discovery, or DMD, which is an approach to solving long mem eval. And this has long been the industry standard benchmark for conversational AI memory. And so this state of the art has actually since been surpassed. There are results now with 100% on long mem eval. The pace of research has been crazy. But what's more important than the score is what it actually taught me about how to build memory. And it's this mental framework that I'm going to share with you guys next. So at the time of DMD, the solutions in the field looked very familiar. You have your standard vector databases, re-rankers, knowledge graphs, the works. And so with DMD, I wanted to ask a simple question. What if we took it all away? And there is a mental framework behind that that led me to this. And it starts with this old idea of Occam's razor. Occam's razor is often summarized as the simplest answer is usually correct. But the phrasing I like better, and that I think matters more for systems design and engineering, is that every additional assumption is new surface area to be wrong. And so where are all my gamblers at? I honestly can't see, so I'm assuming nobody put their hand up. But this right here is a roulette wheel. And roulette has 38 slots, but it pays out as if it had 36. And so on each spin, you have a losing expected value. And by the law of large numbers, the more you bet, the more certain it is that you will lose. And so I want to highlight this idea of making bets and thinking in bets when we build our agents. When we add an embedding model, we're actually making a bet that semantic similarity matches what your agent really needs. When we do chunking, we're making a bet that you slice your context into the right pieces before a question's even asked of it. And when we use a re-ranker, we're making a bet that your ranking of relevance will be better than your agent's. And this all ties into a broader framework in AI called the bitter lesson. And the bitter lesson is this, that general methods leveraging massive computation will outperform approaches built on human domain knowledge. And we've seen it before. It's happened in gameplay with both chess and Go. These are games where decades of research went into encoding how we thought humans play the game and encoding those strategies into agents. It wasn't until we leaned into large-scale search and reinforcement learning, heavy computational methods, that we were able to exceed human performance. And we're starting to see this now with memory as well. Since DMD, a lot of the solutions that have gone on to score 100% on long mem eval, they're all predicated on letting the model do more work, on having truly agentic memory. And so I've talked a lot about why it makes sense that we might have agentic memory, but what does that really mean, and what did DMD do to solve long mem eval? I do have an architecture diagram up on the slide. I'm not going to go too deep into it, but what I do want you to take away from this is just how simple the approach is. There is no vector storage. We just have a file system with raw JSON sessions. We have an agent orchestrator that gets access to a few primitives, file system tools. It can call other agents or other LLMs recursively. And then it gets a plan file where it can kind of update what it's found, what it's not sure about, and what it's still looking for. And so this simple approach outperformed years of research on pipelines and complexity. And so great, we have 100% on long mem eval. We could spin up a simple agent and score super highly on the benchmark. Is memory solved? No. No. And what we see in real life is that production is still hard. This benchmark, and furthermore, this benchmark doesn't actually cover all of the components of good memory that we need for real agents. And so what are those components? The first is a state. Agents are built off of large language models, which are inherently stateless. So if we want our agent to know anything, we'll have to add a place for context to live. The next one is curation. We heard this earlier, but again, LLMs are stateless. So the tokens in will map to what you get in the tokens out. So curation is really a game about getting the right things from the state into that context window at the right time. And the last thing, and what long-mem eval and other benchmarks fail to evaluate, is the life cycle. Our agent is working in the real world. It's doing real things, and the world is changing. So what persists? What do you update? When do you forget, or what do you forget? And furthermore, in production, you're going to have constraints. You can't reason forever. You can't wait forever. And so what comes out of this is that memory is a spectrum. On one hand, you're going to have raw memory, which is memory in a file system, an agent to reason over it and figure it out. That's that DMD style of approach. And I've listed some other popular methods in the field right now as well on the spectrum. And we're seeing that the raw side is actually more performant for the memory benchmarks. However, because you can't wait forever, and because you can't spend all the money in the world, you might need to buy more structure and lean towards the derived side based off of your production constraints. And so your solutions will fall somewhere along this spectrum. It's just a matter of picking your bets. And furthermore, there's some popular failure modes that even with 100% on long mem eval, we still see in real life. The first of these is temporal reasoning. So how do you know what was true when and what changed in between? Entity disambiguation. If you have one session where it says Alvin loves Miami, and in another session it says the best looking engineer loves Miami, how are you going to know that these are really the same person? And lastly is principled forgetting. It's very non-trivial to think about when your agent should forget something and when context becomes stale. And so these are difficult problems that I would urge you guys to take up and help advance the field of memory. And so I want to start to wrap things up with this claim that if you're building agents, you're building memory. Those three components to memory are really the foundation of any effective agent. You need to track what's going on. You need to choose what to take from what's going on to put into that context window. And then you need to update that as your agent takes actions. So whether you call it that or not, if you're building agents, you're building memory. And I know the next talk after me is going to dive deeper into this, but I think Karpathy summed it up pretty well with his comment on calling it a skill issue. And he thinks that today's LLMs can already solve most tasks, and it's just a matter of getting the right things into the right window at the right time. And so I've had a lot of fun talking to you guys today and chatting with you guys over the last couple of days. I do want to urge you guys, if you want to keep chatting, find me in the hallway. We are hiring at OutRival. So if you love Miami, you want to work with a rockstar team right here in Wynwood, and you want to solve really hard problems and make the world a better place every day, please come find us. We do have some OutRivalers in the crowd today. Make some noise if that's you. So please find us after the talk. And I want to just close with some encouragement. This right now is the best time in history to be building. And the time is not just now, but it's right now. And so I hope you all go out into the world, do great things, and make great memories.
Thank you, Alvin. Okay, I want to ask you a few questions. Who's shy here? You are not shy. Don't act. Okay, I forgot. Shy people don't raise their hands. So I'm gonna pick somebody by random, and I want to ask you a few questions. Let's see who we have here. Oh, it's much better. The lights are not in my eyes. How about you? All right. So where are you coming from? What's your name? And what was the most exciting talk you've heard so far, or top two?
I'm from Miami. Exciting talks for me were...
Your name?
My name is Philip. I'm from Miami. I'm like the most non-tech guy here, so all this shit's really exciting to me. The memory stuff that we just did was really cool for me. And then I think, trying to remember, man, I'm just still processing thing.
Are you awake? No, so memory stuff. Okay.
Talk was cool. Obviously, it's like a recency bias, but
yeah, big plus. Okay, let me find somebody else. Don't put your heads down. I'm gonna call you out. That's an old trick. Okay, how are you doing?
I'm good. How are you?
Pretty good. Pretty awesome. What's your name?
My name's David.
David, were you here for the yesterday's sessions, or this is your session?
No, I was here for yesterday's session.
You were, okay. How do you like the MC so far?
Fantastic. 11 out of 10.
Okay, I like that. I like that. So, how many connections did you make in this conference? And did you make any connections?
Yeah, I've made about 6.
Why did you make the face then? You're like you didn't.
I had to count real quick. I'm trying to remember people's names.
Okay, I see. And how did you meet with them? Was it during the lunch, or did you go for dinner or drinks?
Lunch, outside, and then the happy hour last night.
Okay, okay. And how can we improve this next year? Any suggestions?
Longer happy hour.
Touche, touche. Good one, good one, good one. Okay, let's walk around a little bit more. I want to see whose head is down. Now everybody's looking at me. I like that. Okay. All right, hello. How are you?
Oh.
Your name?
Ariel.
Okay, Ariel, nice to meet you. And where are you coming from?
Argentina.
Oh, okay, okay. Directly from Argentina. Okay, let's hear it for Argentina. Which city?
Córdoba.
Córdoba. Okay, awesome. And what do you do? Do you work in AI, or are you in software engineering, non-AI?
Yeah, on AI and a conversational commerce startup from Latin America.
Conversational commerce. You make a lot of money? You don't have to answer that. And how do you use AI? How do you apply AI? Can you tell us more?
Yeah, so basically on conversations where AI make a lot of sense to apply.
So you explained conversational AI to me. You said, in conversations, use AI, right? Awesome, okay. And how do you make money? That's what I'm interested in.
Well, it was interesting, some of the presentations about like outcome-based pricing, and we are writing over it.
Okay, and the most exciting talk for you today?
Gabe about this improvements about how to use and apply for agents and design for them.
Beautiful, beautiful. All right. Okay. So our next speaker is ready. So let's head back to backstage, and we're going to introduce the person who was moderating yesterday's panel. So you've met him already, but he's going to give us an interesting talk, and Ethel is going to introduce him to you.
Yes, I love the engagement, Iman, because when I first read Erik's title for the talk, I thought he was insulting our MC skills, because the title is Skills Issue. Do you think we have any MC skills issue?
Somebody told me we're doing 11 out of 10 over there.
Yes, thank you.
So I believe him.
So we're so glad to hear a little bit more about Erik not critiquing our MC skills, but the skills for your AI agents. So Erik, you have seen him yesterday already. He was on the panel. He is the head of developer relationships for ColdRabbit. So their booth is right there if you want to engage with him more. But for now, he's going to tell us a little bit more about how we can improve skills for our AI agents. So Erik, are you ready to be back here on stage? Give it up to Erik.
Is this working? Yeah? Okay, cool. How's everybody doing? Oh, there you are. Okay. Yeah, so my talk is about MC skills at conferences. No, I'm just kidding. Give it up for the MCs, right? And everyone working AV back there, thank you. And of course, G2I and everybody putting on this amazing conference. Thank you so much. Oh, and the timer doesn't even start when I'm giving thanks to people. This is awesome. All right, so I'm going to talk about skills issues. It is a bit of a pun. I'll be talking about agent skills. I'll also be talking about the skill of using agents. And the goal here is kind of like a reality check. Maybe it's going to feel like super, super simple. And that means that I've succeeded, at least in my view, because we're going to talk about building skills and what that really means, and for me, what learning means. So I'm going to just dive right into it. You may have recognized me from yesterday. Thanks to those amazing panelists, Maxman and Sunil. And just for fun, last night, I built a skill that is called Taste Check that I will share at the end of this talk. It's open source. It synthesizes all three of those panelists' views on taste and then checks anything that any code that you've written against them. So thank you guys for the panel and for letting me obsolete your guys' taste with the skill. So who here has seen something like this meme before? Build me $1 billion SaaS, make no mistakes. Yeah? Okay. So obviously it's funny, but like in reality, like a lot of us actually prompt like this. Where we're like, yeah, don't make any mistakes, make it good. And that it's not really that great, right? It's just kind of us like not thinking. So a lot of times people will see the agent make a mistake or a model make a mistake, and they'll just be like, oh, that's failure, let me start anew. And you're not learning anything, you're not transferring anything from that failure into another session. But the model is the exact same. You know, the weights are the exact same. So sometimes if you view this as like mistakes are a way of learning, so like if you fall down, if you're pushing yourself, if you're trying a new sport, or you are really good at a sport, but you lose a game, you can learn from it, right? You can either just like give up and feel defeated, or you can learn from it. So with agents, we can codify that, what it's learned. And in my personal view, the more you let an agent stretch, the more freedom you give it, the more you can kind of see where its real bounds are. And then as long as you set your expectation that this is going to be an iterative thing, and not an infallible, perfect thing, then you can succeed. The third thing I put here at the bottom is that my view is that you're squandering when you make mistakes, and you're not taking away anything from that. So this is kind of like the semantic space, the domain that I'll be talking about. I think it's a lot simpler, or I'm going to try to make it a lot simpler than all these things. But basically, you've probably seen these terms used before, coming up on like your Twitter feed or wherever. And kind of my experience the last few years has been that like every 90 days, one of them becomes passé. Like, oh my God, I can't believe you're prompt engineering. You're so cooked. You need to be like context engineering or harness engineering or continuously learning with the new memory system, and and then you see this like post that's like, it changes everything if you use this model with this harness and this one prompt. And it does a disservice, I think, to like everybody, because generally when we see that, we get this like sense of FOMO, but it's a false sense of FOMO. Everyone's trying, and the honest truth is there are no real standards. There are a lot of standards, or purported standards, but there are no real standards that everyone's following, because we're all still figuring it out. So if anyone tells you this, either they're a fool or they're trying to make a fool of you. So keep playing, keep exploring. So I've got a few examples here just to demonstrate the difference you can have with the exact same model, the exact same prompts in the field of music. So the only difference here is that it's going to be a different set of skills. So naive prompt, I don't know if I can actually zoom. Yeah, I can, cool. So I'm like, yeah, make me a song. And it just gives me lyrics. That's not really musical. But when when I give it, let's see if the audio works. Hopefully this is not too loud. Is that? Okay. Okay. So tell me if you feel like emotional about this one. Can I play this? Does this give you any emotional vibes? Yeah. So that is a skill using ABC notation, which is basically like a markdown extension that then like you have some runtimes that will take that, convert it into like MIDI. And then this other one, this is me showing off a little bit of a few different skills that I combined together. I think that it's not going to work on the Wi-Fi, but like here's the site that it created. This is, you'll see this kind of like site format. And let's see if I can actually. If you like country. Let's see if we can get some of the lyrics. No childhood to keep. This is like Claude expressing itself in song with a bunch of skills. It picked country because I guess it was feeling sad or something. All right, we're gonna keep it going in the background because I think it's fun. So yeah, it's actually the exact same lyrics that were written in the first prompt. I just like added to the agent session there. These other skills, and I was like, go make it good, and it just used those. So this is kind of nice to have music while you're playing. It's relaxing. So the gap, in my opinion, is the skill, I just demonstrated you can use the exact same model and just slightly different engineering. I will say that those skills, the website one, not that difficult. The like controlling a digital audio workstation with Claude, that one took a lot of iterations. Kind of a passion project for me. But some other ones I have, I can show these too. So you can see these like combination of skills. And there's Claude telling me that it's going to be difficult to switch and still be entertaining. So this is one I run as a scheduled task, like every Friday morning to tell me like all the features that. So I work at CodeRabbit, so it goes and figures out like all the things that we ship. And which one had like the most impact based on our metrics. And then I don't want to look at all that, so it just writes me a song. So, like songs have a lot of like Shannon information or whatever. So that's what my excuse is. I also have another one. It's bedtime stories. It's like audiobooks. I probably have to like pause the country.
Once upon a time, in a shimmering city by the sea, a builder named Thorsten.
It's definitely not about me being nervous about giving a talk today.
Now backstage, Thorsten took a deep breath and walked into the light.
So there's something like
when he finished, the room was quiet for one heartbeat.
I guess I hope it's quiet, like in a good way. Like
afterward, the most wonderful thing happened.
Something wonderful is going to happen after. Cool.
That night,
and I play guitar, obviously.
Strumming his guitar.
So that one. Thank you. Thank you for following the storyline and clapping and being happy, and it was a good talk. So that one is also a combination of a lot of different skills. One thing that like always kind of made me wonder is like, why does Anthropic not make like other models besides like LLMs? So then I realized like if you're just a really good agentic model, that's kind of all you need, and you can let other people make the models. So this one uses text-to-speech, like 7 different text-to-speech models. The skill, I go back and forth, I'll talk about that in a second, but it also uses, I think, about 8 or 9 different image gen models, depending on what it needs. So for the bedtime story, like meta skill, it's just using those underlying ones to inform it of which calls to make to get what kind of audio, what kind of images, and then maps it so that the little highlighting of the words there's a CSS issue. I don't know if you saw it. It's like a few pixels off. That's not the hard part. The hard part is like cutting the audio, figuring out where words are, and mapping them to it. That one took a really long time too. But I have 2 little kids, so passion project. And then, oh yeah, we got to get back to the music. Let's see. Let's do like, you guys like house? Ooh, I got an immediate yes. Awesome. So house music is actually kind of an easier genre for models to use because it's like, I can turn it down just a little bit, yeah. Because it's electronic and you can control drum machines on it. Anyway, I'll distract myself talking about music all day. So basically, I think it can be this simple that if you think of the models as the primitive, as the main primitive that you're just trying to work with, you can use the file as the substrate or the medium, the place that you're doing things. The prompt is like the intent. The tools are the skills that you write. Those are just calls that are going to be made, and then and loop over that. I think it's very easy to like jump into like premature optimization, especially with models, especially when there's not this like super clear path that we're kind of can read a giant textbook about, and we can build out huge systems. So start small, and just like if you can one-shot it, that is fantastic. I wouldn't call that a skill though. It just means it's part of the model already, part of the harness. Anybody can do that. You're really just writing documentation for what is already there in the latent space. And maybe more importantly too, if you can one-shot the skill. So how many people here have made skills before? Okay, how many people have iterated on that skill? Wait, that's more hands than originally. Yeah. So again, too, like if you can just write the skill once, and it works every time, you probably don't even need that as a skill. It's just extra context tokens. The front matter of that skill is going to have to read into context. You can just skip it. Another really interesting thing is when you're building stuff, don't use the best model or just wait for better models to come. So worse models in the same family, and I give this 4.6, 4.7 one because the digital audio workstation skill or set of skills that I originally built with Opus 4.6, and still had like a lot of frustrations. The 4.7 came out, and I was like, oh, like it just did it and didn't fall into the same failure modes. So using weaker models, if they're in the same family, tends to give you these constraints, these forcing functions. It allows you to be specific about the failure modes while you're kind of co-working with the model itself. And the specificity there survives model updates. It survives like harness updates, etc. So like do the hard work now, invest in it now, building like really good skills, and then they'll just get better. So maybe this is a little too musical. It's a rhythm. So just start small, like something that you want that you're having frustrations with, like an agent or a model performing. Just do it, but then pay attention. Look at co-investigate with the model. Don't fall into this mode where like you think that you know better and you'll tell it exactly what to do. You should co-investigate it, help the model like work with you to get better, and then codify those things. A couple of failure modes, overgeneralizing. So write good music. We got just some text, or overspecify, especially on failure modes. So like a lot of times the models will be like, oh, I'll never do that again. I'll just stay away from that whole domain. That's not a good one. You should understand why it failed exactly and codify that. So for instance, like when I first wrote this like music generation skill, I wrote it with Claude's skill creator, and it was like, okay, here's 10 genres. This is what we're going to work in, because it's a lot more effort to do more. We kill the expressiveness, we kill the potential output space, and lower the local maximums. So stay close to the meta work. If you're like, oh, I need to be having my background agents run while I'm sleeping, if you're that kind of like AI psychosis level right now, stay up and do the meta work, do the skill creation work, do the iterations, get it in a good spot, and then you can sleep while the skilled runs are running, and then reflect on them. Always have loops every time it runs a skill. Anything that it learned while in that session, it should reflect and add back into the skill. It's really cheap to iterate on these, dollar-wise, token-wise, but it does take a lot of work. There's no such thing as a free lunch. I've been saying this term for like the last year and a half or something called GOFI. I totally made it up, but it just means good old-fashioned engineering, y'all. Yes, it's just good old-fashioned engineering. So another way of saying this is why spend 5 minutes codifying the lesson in a skill when you could spend 5 days watching the agent fail with vibes. So just stay focused. Maybe one thing, who here thinks that we've solved continuous learning or we need to solve continuous learning? That's two opposite questions asked at the same time. There are a lot of these talks out there that are like, oh, like we're not going to have like super intelligence until we solve for this continuous learning thing, and no one knows what that will be. No one's able to define it. So it's very hand wavy, and I think it's BS because you can just write things down. Like as simple as this talk is, which I hope it's landing as a very, very simple, straightforward talk. You can just write things down in a skill. That's memory. You can have that in the context going forward in the future. That's memory. It's learning while it's running and then saving that somewhere. That's memory. Like, I don't know how many other ways to say it. But you can get more out of the models. So we need some kind of like futuristic predictions or something like that. So like, where is this all pointed to? I'll have 2 slides on this. One thing that I think is really interesting and really, really powerful, I tried this out a few months ago with a Nematron model, building like a very, very simple coding harness in a terminal for a Nematron to run, but giving it access to its own code base so that it can write evals and then and run those outside of its own loop. There's other things like skill creator skills that help agents create skills for themselves. There's PyAgent, which is like purposely very, very simple bare bones, but then has this extensibility. So these are like self-modifying agent harnesses. I think these are really interesting, as long as you keep an eye on it, even like on that kind of self-iterating loop. And then the other thing is like zooming out a little bit. The things that you can do with your skills today or with your agent harnesses today that the model can't do itself, the model will be able to do in the future. It just takes a while to do the training to get those new skills and those new capabilities into the weights. But skills are a way in between any of the ML stuff that ML researchers would be doing and just prompt engineering. So wrapping up here, really, you should make some or many mistakes. The more, the better. The more mistakes you make, the more you're pushing things forward, the more you're differentiating. And you can help the model learn from them itself. So being there with the model and helping it through its struggles is good. It won't remember that, but it will perform better in the future. And that way you can not make the same mistakes again. And this might sound weird, but building model empathy, I know people have their preferences on which model they like the most. Tends to be the one they think is the best as well, even though those things should be different. But if you just keep playing with these and keep seeing like where they fail and what actually helps them succeed, you can build some empathy for them. And I will note that some models do need a sense of psychological safety, in my experience, to perform at their peak. Speaking of, does anyone want to hear some absolute bangers that Claude wrote in a digital audio workstation? Yeah? All right. So do you guys like metal? All right. Let's see. Oh no, I paused it. This is Claude expressing itself. I figured like Claude is like known for being like the nicest kind of models. Like, let's do some gent metal. So while this plays, it's sick. It's sick. I'll share all. Actually, you can go to hyperoperator.vercel.app and you get like 6 different versions of this song. So Claude deployed it. Results will never be 100%, so never be looking for that ever. We're always dealing with probabilities with models. We can get damn close to 100%, like good enough for production, for scaled out things. And if none of this makes any sense, or you're like, oh, he's just making music, when you put it in a business context, every mistake that you solve for is a differentiator for you, because you can go further than anyone else can go in the market with just the model. So going back to the meme, build me $1 billion SaaS, make many mistakes along the way. Let's learn from them together on every run so you do better next time. Thank you all. Did I just like walk off stage? All right.
All right. What a great talk from Erik. So who here today is going to write a new skill after Erik's talk? Raise of hands. Amazing. Who is going to make some edits to their existing skills? Okay, awesome, awesome. Okay, so we're gonna go for a break, and then after the break, there are gonna be 4 more talks, so get ready for that. And just be back at 3:45, so you can hear all the amazing talks for the end of the day. And the last session is gonna be really interesting. We can probably even start a debate about CLIs versus IDEs, so definitely don't miss it. All right, I'll see you at 3:45.
Yeah, we're good on binary.
Ladies and gentlemen, please take your seats. Our event will start in 5 minutes. Ladies and gentlemen, please take your seats. Our event will start in 2 minutes.
How are we doing? Great. I see you, Ryan. That was a nice woo. Okay, our next presenter is an open source champion. He loves building and developing open source software and also loves educating others. And he feels lucky enough to do both for, as his job for a living. And he has been at a few startups like Vercel and also ran his own game marketing company for a while. It's my pleasure to invite Hassan to the stage. Please welcome him.
Thank you so much, man. Appreciate it. Hello, everybody. Thank you for coming. My name is Hassan. I lead DX over at Together AI, and I'm very excited to be here today to talk to you about one of my favorite things in the world, which is building AI apps. I've been fortunate that some of the apps I've built have done pretty well, so I'm just here today to talk to you, to show you some demos of stuff I've built, to talk to you about how I build these apps, what coding agents do I use, what tech stack do I use, talk about my process from going from like idea to deployed app, and I'll end off with some lessons I've learned along the way. All right, so introduction, like I said, my name's Hassan. I build AI apps. That's the main thing you need to know about me. I've been building about 10 to 15 AI apps every year for the last 5 years, so I have a bunch of apps built. Some of the apps I've been lucky enough to have gotten a couple million users. And also, all of my work is open source on GitHub, so github.com/nutlope. I build these apps with AI models from Together AI, which leads me to Together AI, the company I work for. We're an AI native cloud platform for running, deploying, and training open source models. We have a bunch of different models across the stack. We have like chat models and code models like GLM 5.1 and Kimmy 2.5. And the Minimax models, we have image models like Nano Banana, we have audio models, both speech to text and text to speech like Whisper, we have vision models, we have embedding models. Basically, any model that you want to use to build your app, we probably host on our inference API. We also give kind of more advanced teams who have a lot of data the ability to fine-tune models from scratch on their own data with kind of LoRa fine-tuning or full fine-tuning or even RL. And lastly, we let teams launch GPU clusters, whether you want 8 H100s for 10 hours or thousands of GPUs in a really, really big cluster for a while. So that's together. We have some cool companies that use us here on the bottom. Cool. So before I get into demos, I just want to talk about why it's a really great time to build right now. Obviously, with coding agents, everybody can move a little bit faster. Code is really cheap. You can try out your ideas and test them out really, really fast. But also on the other side, it doesn't mean you should ship 10 features because you can, and it doesn't mean you should just kind of like blindly ship. I say there's a right way to do it, but really, there's no one right way. I'm just going to talk about my way and how I do it personally. But I think like it's a blessing and a curse that you can move so quickly, but at the same time, you still have to be intentional over what you build and how you architect your apps. All right, so let's get into some demos. So this is a list of some apps I've built. The main thing to take away from this slide is the number of people that use the apps vary a lot. And honestly, I don't know how many people will use an app when I've launched it. I don't know if it's going to be 500 people or 1 million, still to this day. So I think like a big piece of advice that I like to tell people is just like keep building, and it'll kind of eventually pay off. So yeah, we'll go through a couple of the apps I've built. One of them is kind of an open source v0/lovable app where you can come in and ask it to build you something, and it'll go and build this stuff. So I built this about 2 years ago. And I built this when open source models started to get really good at coding. So here it built a little front end, like Trello-like front end. I have about a little over 2 million people that have used this app over time, and about 7,000 stars on GitHub. This is another one that I built called Blinkshot. I built this because this new image model called Flux Chanel came out, and it was really, really fast. On our API, it's like 800 milliseconds on average. So I built this like real-time image generation app that as you type, it'll generate images, and you can also change styles, and just to kind of show off image models. And so this app has gotten, I think, about 30 million images generated in the last year and a half, and a little over 1.5 million people that have tried it out. Another app. So I'm super passionate about education. Both my parents are educators, and so I wanted to build kind of an AI personal tutor that could teach at different levels. So I built it, using web search called Llama Tutor, and I've had a bunch of people try it out as well. Another one, I wanted an interface to be able to easily edit images, and you can do this on ChatGPT, but also I wanted a really nice interface where I can go back and see a list of all the variations on the top left. You can see we have V0, V1, V2, and you can kind of continually edit images and keep going with them. So that's easy edit. This is another one that I built called AI Commits, and this one I actually built a very long time ago, almost 4 years ago. I saw someone, Theo, tweet out like, oh, I wish I could use AI to write my commit messages. And this is before the age of coding agents. And so I hand-rolled a CLI that can actually generate commit messages. It looks at your Git diff, and it writes commit messages for you. And so this one, I have about 45,000 developers that have installed it and tried it out, and a bunch of stars on GitHub. I built my own chat app that exclusively uses open source models and has web search and can generate images, and you can branch chats and do all the cool things. Yeah, this is, like I said, exclusively using open source models. Have a bunch of people that have tried it out as well. This one I did to show off how you can use vision models to actually do OCR. And so you can extract structured information. You can extract JSON as well with it. So that was last year. Generating logos. I build a lot of these apps, and for every app I build, I love having logos. So I built a little interface and did a lot of prompt engineering, and came out with an app that works fairly well for generating little logos here and there. Upload a screenshot and get code, right? There's just like a lot of these apps that I've built because of problems I've seen online, or like this one was I go to all these restaurants and I never know what's on these menus, and so I wanted an app to send a picture of the menu and for it to actually give me all of these images. This is one of my favorites lately that I built a few months ago called Make Comics, where it'll generate a comic book for you from scratch. You can upload pictures Yeah, you'll get a full-page comic book in different styles, and you can keep going and keep generating more and more pages. We actually used this one at a conference we did a while back, which was cool, where people could come into an iPad and take a picture of themselves and generate a real comic book that we printed. And these were some of my favorite ones. The Rubik's Cube guy I especially like, because it captured kind of exactly what he was wearing, and it put it in the comic, which was kind of nice. This is one of the last ones that I built, where you can upload a video and get subtitles. I make a bunch of videos for my job, just kind of educating developers on how to build this stuff. And depending on the platform, I want to add subtitles, or I want them to be structured differently. And so this is an app I built that lets me do that. Lets me add subtitles to any video I want. So those are all apps I've built. I have a couple ones that I'm working on right now. One of them is called Orchestrator. You can spin up a bunch of Claude codes in the cloud, ask them to do stuff, and it'll open a PR for you. You can actually sign up orchestrator.build if you want to join the waitlist. Yeah, you can spin up OpenCode instances or Claude Code instances or really anything you want. But yeah, this is one of the apps I'm working on, and the other one is, like I said, back to education. It just builds a personalized course for you based on any materials you have. So for this one, I uploaded like a research paper to teach me about transformers, and it'll kind of go through and construct basically an entire course for me. OK, cool. So those are some of the apps I've built. I'm now going to transition to talk about how I actually build these apps and what I think about when I do. So what's my agent stack? Before that, actually, I want to talk about the architecture of these apps. So these apps are quite different. But an interesting thing is that almost all of them have the exact same architecture. Almost all of them have, I start off with an input, right? Some kind of text input, put in a text, and I'll generate an image from it, upload a PDF, upload an image, whatever it is, but it's some sort of input. And then I send it to an AI model that generates something, generates code, or it's a vision model that describes what the image is, or whatever it is, stores it in some sort of database, and then it sends it back to the user. So a very simple 4-step architecture for a lot of these apps. And I intentionally like to keep a lot of these apps very, very simple as well. So this is the actual tech stack that I use, like I said, together for AI models. I like to use Next.js. It's a nice full stack framework. I use a serverless Postgres database called Neon. I use Clerk for authentication. Drizzle is my ORM. S3 for storing, object storage, storing images and PDFs and that kind of thing. Plausible for analytics, and Vercel for hosting. So with people's tech stacks, I like to say, do what works for you. If you have a tech stack that works well, continue going with it. I've kept mine largely the same over the years, just so I can move as fast as possible. Harness stack. So this one's a little bit interesting. So I use Codex for prototyping apps. If I have an idea and I want to get something in 30 minutes, and I don't mind throwing away the code, I'll usually use Codex for that. They have a pretty good desktop app that they've released recently. I'll then use Cursor for a lot of my everyday, like I want to add a new feature to an app, or I have this very large app and I want to be able to read code. For when I need an IDE, I use Cursor a bunch. And then Claude Code, I mostly use it for PR reviews. I like to use different models for writing my code and reviewing my code. I notice that tends to help a little bit. Cool. This is a question I see a lot on Twitter, which is, should I be running like 1 million parallel sessions to build everything that I can possibly build? And usually what I tell people is, no. I don't think you need to spin up 10 or 15 sessions. I think multi-agent orchestration is really cool, and I think you can use it. And if you have 2 ideas at the same time, you can do that. But I usually find that the gains stop after 2 or maybe 3 parallel threads. So that's what I've noticed works the best for me. All right, process for building these apps. So I have this 7-step process. The first one is I always have a list of ideas. I have a list of about 150 ideas right now that are kind of stack ranked. And anytime I think of a new idea or get inspired on X or Reddit or wherever else, I add it to this list. And so I have this running list of ideas. So anytime I want to build, I don't have to sit and think about, what should I build today? I can just go to the list and read the top 10 or top 20 and pick one of them and go and build it. So then I come up with a good name for it. I think through how it's going to work a little bit. I don't just send it to an agent right away and be like, hey, build me an app that does X, Y, and Z. I try to think about, OK, this is going to have one screen, and I'm going to ask the user for this, and then this is what's going to be output. So I try to think through it just a little bit and give the agent a little bit more context. I try to build the simplest version I can of it. Sometimes I'll come up with a very grandiose idea idea that has all these things, and I have to like ground myself and be like, okay, what's the simplest possible version of this app I can ship? And simplicity helps in a lot of different ways. Number one, it's quicker to build, which is great. Number two, it's generally a lot more consistent. You know, if you build an app that's really simple, it's probably going to work fairly well most of the time. And number three, you can actually describe it a lot better. You should be able to describe all of your app ideas in like 5 words, or at least the MVPs of them very quickly. So number 4 is build the simplest possible working version. Number 5 is figuring out authentication and limits. I usually have a free tier on every app that I launch. So I think through, you know, do I want them to sign in with Google? Do I want to rate limit by IP address? Do I want to just have like, you know, put in your own API key to use this thing? So thinking through that and then preparing for launch. Like I said, most of my stuff is open source, so I write a good README. I'll buy a nice domain. I'll have a good OG image. I'll add analytics. And then number 7 is just like, you know, draft some social posts, launch it, and keep an eye for any feedback. Cool. And then this is what I'm going to end off with, just a couple of lessons I've learned in just general advice for building these apps. Number 1 is keep shipping. You know, I showed you guys that screenshot of all the apps that I built and the number of users, and it fluctuates widely. You know, so I think like a lot of apps that I do don't do very well. A lot of apps that I build and launch don't do very well. So I'd say keep building. You got to put in the work. You have to put in the reps of just like building stuff and launching and building stuff and launching and kind of learning from what you launch as you go. Tip number 2 is make sure it looks good. Sounds super obvious. You'd be surprised how many people don't do this. Very few people will use your app or take it seriously if it's not easy to use and if it doesn't, you know, feel good. I build all these AI apps, but I actually spend, you know, over 80% of the time focusing on the UI, which sounds really counterintuitive because I do spend time on the AI portions and like what AI model should I use and how should I chain them together and how do I write my prompt and all this stuff for my apps. But the UI is just so important. That I always spend the majority of the time on the UI and making sure it looks really good. I'd say if you're using agents, try to be specific. Don't just say, build me a nice app that does this. Be a little bit more specific. Agents love screenshots and references for like other apps that you like. And then you can just iterate slowly and break it into steps and try to prompt your way into like an app that looks quite nice. So tip number 3 is keeping apps simple. I already talked about this a bunch. Code is really cheap now, so a lot of people fall in the habit of like, oh, I'm going to build an app that does like 12 different things. And the thing is, you can build it, kind of, and then it'll mostly work and all this stuff. And I think that's how we get a lot of AI slop is like, you know, building a really advanced app where half the features fall apart the second you try to use them. Almost every single app I've showed you has like 1 API endpoint, at the maximum 2 API endpoints. So just keep things simple. Work with coding agents step by step. Test at each step. Actually read the code, you know, one small task at a time. I think coding agents are getting smarter and smarter, but the more you can actually like break things down and think a little bit through them, the better I've found them from my experience. This one is one that I do a lot for a lot of my apps, which is to incorporate the latest AI models in there. So AI models are dropping all the time. And a lot of the time, a new AI model drops that kind of unlocks a new capability or unlocks or just like is significantly better at something very specific. There was a model that came out that started to get really good at like image to code. You know, give it an image and generate code. And so I just went and built an app with that, and it did really, really well because it kind of wasn't previously possible, or at least it wasn't previously possible to do in a really nice way. So I always recommend, you know, use the latest, if you're building AI apps, use the latest AI models in there so it's more impressive. This is an example where I did that. Nano Banana had just come out, and this is like 2 days after I built this app, where you can upload a PDF, and it generates an infographic for you. And it sounds really cool, but really, I take the PDF, I scrape the text, I send it to Nano Banana, and I show the user an image. And so it's so simple. I built it in a very short amount of time, but it did very well on Twitter and got thousands of likes and hundreds of thousands of impressions and everything like that. And it's because it's a new capability. You know, image models previously were not able to you know, build these really nice infographics. So I love this concept of like keep up with the latest models and try to build something cool with them. And then I think this is my last tip is relaunch apps with new features and new models. A lot of the time I'll build an app And then a year will pass by, and then models are just so much better that you know, when I replace an old model with a new one, it kind of drastically changes the app, or like it becomes significantly better to the point where it feels like a new app. And then I'll just go and relaunch it and be like, hey, here's version 2 with an updated model and all of this stuff. And so that tends to do quite well with these apps. Awesome. That's all I have. Thank you so much for coming. And yeah.
All right. Okay, 3 more talks for today. Okay, before I introduce the next speaker, who is also a prominent figure in open source, I have a question for you all. Who is a dog person? Show of hands. Okay, I see some hands. What about a cat person? Do we have them in the room? Or are they back in their houses, staying in their rooms? Okay, no cat person. Okay, that is good because our next speaker has a 3-pound Yorkie that he wasn't able to bring today, but it would have fit in his pocket because the dog is so tiny. But Stefan is going to present to us the multimodal future, and he believes that the multimodal future is open source. So, Stefan, welcome to the stage. Okay, so Stefan is the head of business at OpenCode, and we already heard from Dax, who is the opener for our conference as the founder of OpenCode. So today, Stefan is going to show us the multimodal future. So take it away. Thank you.
Cool. Is this working? Test. All right, cool. Can you guys see my slides yet or no? Not yet? All right, let's do entire screen, start mirroring. Perfect, can we see that? Okay, great. And Dax wasn't lying. Wow, this is really bright. I can't see anybody, so I'm gonna imagine that this room is full. So that's kind of how we're gonna go with it. Today, we're gonna be talking about how the multi-model future is open source and why the best AI coding tools don't pick the model for you. I gotta make sure I stay here because I guess it's gonna keep falling. Cool, so again, my name is Stefan Avram. I am the head of business. I'm not the CEO at OpenCode. We have this long-running joke, which is people think Dax is the CEO or Frank, and so we kind of like put that in there to clarify. So I'm not the CEO. Previous to this, I co-founded WonderGraph, which is an open-source API management solution. So primarily, I spent my career in open-source technology as well as developer tooling. I reside right here in Miami, literally like 1 building over. And I know that the MC said that I was going to bring my Yorkie. I really was. But my wife was a little bit scared that this tiny dog might start peeing on the stage or something, and so I didn't bring it. But she will be around for the after party, if you guys are around. And also, if you're staying for React Miami, you might see her. Best way to get in contact with me, email, or you can get in contact via Twitter. So Stefan, TMD. And then also, I'm the only business guy at OpenCode, so the easiest way also is LinkedIn, funny enough. But again, these are the ways to get in contact with me. Cool, and I don't know if this clicker is working, but we'll just kind of stay here. And today, it's a really exciting time, especially with like AI engineer and everything that's kind of happening. And it's really cool to kind of be at OpenCode, to kind of be on the frontier and like seeing what everything is happening. And we're kind of living right now in this golden age of models, which I don't know why it's not working. There we go. And we're kind of living in this like golden age of models where new models are dropping every single day. Does it keep going out for you guys, by the way? Okay. So I'm going to just stand here and make sure it doesn't move. And again, we're living in the golden age. New models are being dropped. Yesterday, Kimi 2.6 dropped. We have a couple new models dropping this week on OpenCode. And we kind of stay very close. So as soon as it drops from a provider, we add it into OpenCode. And it's really exciting because I get to work with Frank and what we call our inference team. But it's also very exhausting. So I think you guys are going to relate to this next slide, which as a developer, again, it's like cutting out. Can you guys see the meme or no? Oh my God, what is going on? Okay, sorry guys, technical difficulty. Let me see. One second. Can we see that? Okay, so I think we can all kind of feel this way, especially every day a new model drops, a new model provider is created, a new company raises a, I don't know, $100 billion seed round, and so it's kind of exhausting. But I wouldn't have it any other way because it's really exciting time right now to be building in technology. And yesterday, as I mentioned, a new model drops, we have to have it into OpenCode on day 0. So definitely kind of feeling this way as these new models are dropping. And it's really important to kind of understand why this is happening. And so there's an interesting trend that I'm kind of seeing across these enterprises, which we'll talk a little bit about here, which is these companies tend to go through this AI adoption phase. And we call them the 3 Rs, resist, rush, and reign. And what really happens is, I also saw this on like Twitter, which was fantastic because a lot of people are also seeing this. But the first one is like reluctance. And this is rightfully so. You might see on X, you might see on LinkedIn, or any of the headlines that developers are going to be replaced. And so when we've had the same workflows for 20 years, and people are saying that AI is going to completely replace us, obviously there's some reluctance to kind of try out these tools. And so stage 1 is this reluctant stage. Stage 2 is based off my favorite movie, if you've ever seen it, Everything Everywhere All at Once, which is the rush stage. We're just throwing everything at it. AI is everywhere. We are now an AI-forward company. We change the workflows. AI is everywhere. And I've also seen this with companies that make no sense. So for example, now you have like AI-powered toothbrushes, AI-powered jewels. Everything that we're doing is now with AI. And so we're just overspending. We're just going. And then the last one is where we see this transition from stage 2 to stage 3, which is the tech works. We call this the reign stage. And the way that it works is now we actually make it efficient. Per token costs matter, right model for the job, and we start to move the business needle towards what actually is really useful for us as a business. And of course, I had to put in LinkedIn. So this was on LinkedIn Lunatics. But this is phase 2 in its natural habitat. And so I'll give you a second so you guys can see this. But these are actual conversations that we're also seeing at OpenCode, which is people are literally token maxing. They don't care about their spend. They don't care about their costs. Their CTO said, hey, we have a top-down initiative. We need to spend as much as we can. We need to become AI-forward companies. And so I saw this on LinkedIn, and I was looking at it, and I wasn't going to put it into this talk. But then I looked at the guy's profile, and I couldn't tell if he was kidding. And I think that he was actually serious. And so I had to throw this in there because in stage 2, we actually are having these conversations at OpenCode, which makes sense because, again, they're getting these like vibes that they're going to get left behind. They need to adopt AI. And so they started to post like these things on LinkedIn. And so phase 3 is where I spend most of my time. So as companies are moving from reluctance, and then now they're throwing AI at everything, they start to hit stage 3, where model choice starts to matter, the cost matters, and control matters. And so this is really where OpenCode shines. And it's also a really, really important part for developers where you want that flexibility. And so this is just a little screenshot from inside OpenCode. So last week, Kimi K25 was our most popular model. Obviously, this week, that's not going to be the same thing. It's going to be 2.6. You can see Opus, you can see GLM. I've been daily using GLM, which has been my go-to model. But every week, it changes, which is a really exciting time because you want that model flexibility. And so what's interesting, we also have internal benchmarks within our team. And we really try to see which models that the team is using. And so the first pillar inside of that point when companies are moving from stage 2 to stage 3 is they start to experiment with some of these models, whether they're SOTA models or whether they're closed source models. But they really start to experiment and really try them out. The second one is cost. And so you might have seen this headline or you might have seen this on Instagram or on X. But the Uber CTO said that the AI coding tools have already maxed out their 2026 AI budget. And so Uber is just one example of this, but we're also seeing this across big enterprises that come over to OpenCode, which is, hey, these tools are great, but they're starting to cost more than junior developers. Maybe it's actually better we hire junior developers and get rid of the AI coding tool. And what's interesting is that the cost varies, 60x across the cheapest to the most expensive ones. And it's really interesting to take a look at that because a lot of the AI tools, credit given, they've really pushed technology forward, but they were really built for phase 2, which is that rush phase where we're just throwing AI at everything and we're really trying things out. The last one, though, given my background in open source and with GraphQL Federation, we spent a lot of time in API infrastructure. And this is probably my favorite part that I start to see at OpenCode, which is control matters. And so we have a case study with Ramp where they built Inspect, their own background agent on top of OpenCode. And the way that it works is because OpenCode was open source, they were able to build on top of it. And it really kind of moved the things from stage 2 to stage 3, which is delivering that business value. And so 30% of Ramps merged PRs are now written by Inspect. It was built in a couple months. It's fully customized to their stack, their tools, and their workflows. And again, this case study is public on our website. And these are the 3 pillars that we typically see when companies are moving from stage 2 to stage 3. And this is something that I was talking about Dax today. And Dax, he was the one that did the keynote, which is a lot of these ideas that we have, they're not necessarily good ideas at first. We've just been able to kind of supercharge them with AI tooling. But we've seen this movie before, which is there's closed source, there's open source, and they start to compete with each other, and they actually start to drive each other forward, whether that's with databases, compilers, or code editors. And when I was in Japan this past couple weeks, I spent a lot of time there doing some like history stuff. And one of the tour guides, he told us, he's like, to study the future, you got to go back in time, which makes sense because we've seen this before, and it's exactly what's going to be coming with AI coding tools and why open source and closed source tools are important. And if we start to focus on the frontier models and the SOTA models, the value starts to move up the chain, which is that inference is commoditizing. And so Kimi 2.6, I heard a couple like whoops when I said that we had in OpenCode. It's a fantastic model. And you can start to see in this chart from bench.l.ai that it's starting to get closer and closer and closer. And these frontier models, because of this, and these open source models, they start to push each other forward, which is a great thing for both parties involved. And what's also interesting is that we have massive capacity from these neoclouds. These big clouds are racing to serve inference. Everybody is now offering to serve instance, which pushes us to offer these models, whether it's open source or closed source. We also have these open source models that are now enabling this competition with these frontier models. And these large companies have growing incentives to fund these open source alternatives because they're starting to make these frontier models cheaper, they're starting to make them better, and it all pushes the whole ecosystem forward. And I knew I kind of flew through this talk because it's really an exciting time right now in AI, but there's one thing that we really want to focus on over here at OpenCode, which is what this means for you. And so if you're building tools, start to design with model flexibility from day one. If you're choosing tools, ask who owns the model decision. And if you're in phase 2, start planning for phase 3. A lot of the companies that are coming into OpenCode, they're either in phase 2 into phase 3, and they start to see that they need to kind of aggregate the choices. They're using everything now, but eventually they're going to start needing to pick between one tool and two tools. And then the last thing is, it's kind of something personal, something we've really been enjoying at OpenCode, which is there's a lot of noise out there saying that developers are going to be replaced, that we're going to be replaced by AI. And we kind of have this message going around, which is it's really important to remember that AI can't build great software without you. And so we kind of have this message going, and we really want to kind of nail it home that regardless of what you see in the headlines, that you guys are needed. AI can't build great software without you. That's it. That's my talk. Thank you guys so much. Thanks. Perfect.
How's everybody doing? We're almost there. I'm getting separation anxiety. But anyways, so you built your agent. Where does it actually live and run? On the CLI or an MCP server? Our next speaker is Laurie Voss, who's been a developer for over 30 years and was a co-founder of NPM. And he believes passionately in making the web bigger, better, and more accessible to everyone. Please join me in welcoming Laurie.
Hello, everyone. They were not kidding when they said you cannot see anything from up here. Like, really nothing. Come on, present full screen. Thank you. Excellent. Hello, everybody. My name is Laurie Voss. I am head of developer relations at Arize AI. Like you said, I've been a developer for over 30 years, so I have some blog posts that are older than some of you. And in a former life, I co-founded NPM Inc., so I used to spend a lot of time talking about JavaScript. Now I spend a lot of time thinking about how to make AI apps better by using evaluations, which is what we're talking about today. We're talking about agents and how to make them useful and efficient, which is important because we're all using agents every day to do stuff. So if we can make our use of agents slightly better, then we win. Specifically, I'm going to be looking at how we give them tools. There are two very popular ways of doing that. One is MCP, and the other one is command line via skills files. And I'm going to talk about which one is better. And we're going to talk about when it's better and why it's better. But instead of just having a hot take about that, I'm going to use actual data. I'm going to use evaluations to figure out which one of these works best for us. And then we'll look at that data and figure out what it's telling us that we should do. So first, what is MCP? I find it very hard to believe that anyone in this crowd needs MCP explained to them. But just to be crystal clear about what I mean, MCP is a remote tool protocol with a discovery mechanism built in. That is the two important facts to remember about MCP. It is also super popular. The SDKs get nearly 100 million downloads every month, and there are over 17,000 MCP servers that we know about. A skill, on the other hand, is just a markdown file. It tells the model how to do something. Often that means how to use a command line tool, but it could be how to call a particular REST API or just how to follow your team's coding standards. And you just give a markdown file to the agent, and it just does the thing. There's no protocol per se. It's just a very loosey-goosey natural language thing that LLMs excel at. But it is the same thing as MCP. It is a method of calling remote tools with a discovery mechanism built in, even if that discovery mechanism is look in the skills directory. Skills are also super popular. Skills.sh lists over 90,000 skills, some of which have been installed millions of times. But those numbers alone, the adoption numbers, don't tell the full story, partly because lots of skills are auto-generated, and not a lot of skills are not necessarily about remote tool use. 6 months ago, MCP was the hot new thing. Everybody was building MCP servers. And then Anthropic, who also invented MCP, invented skills files and told everybody about them and ignited a debate. My friend Simon Willison, who writes a lot about AI, said in October of last year that Claude skills are awesome, maybe a bigger deal than MCP, which is a very spicy take from a man who does not usually indulge in spicy takes. And then in February this year, a blog post titled MCP is dead, long live the CLI, went to the top of Hacker News, and it stayed there for 2 days. And the argument was simple. LLMs already know how to use CLIs. Give them a shell and some docs. Stop building servers, stop writing schemas, just let your LLM run commands. And just to pile on, Peter Levels.io on Twitter said in March, MCP is dead, just as useless of an idea as LLMs.txt was. It's all dumb abstractions that AI doesn't need, which is 2 piping hot takes in one. But the problem here is that this is a very online debate. It's tweets and it's vibes and it's people making claims without a lot of data. And I like data. You've heard people on both sides of this debate give talks both yesterday and today. But I wanted to run a proper evaluation and see, with data, which of these things works better and why. And because a good eval is hard to write, I started this several weeks ago and was still running my evals until Sunday night. But I think I have some pretty useful numbers now. But before I show you the data, I want to know 2 things. First, which one do you, regardless of which one you think is better, which one do you prefer? Raise your hand if you prefer MCP. Raise your hand if you prefer skills. OK. Raise your hand if you think the winner in this is going to be MCP. And raise your hand if you think the winner is going to be skills. OK. Well, we'll see. Here is the experiment that I'm running. I took one model, Claude Opus 4.6, because I don't pay for my tokens. And I gave it a set of tasks to perform against GitHub. Using the Claude Agent SDK. So this is the same SDK that powers Claude Code itself. So I gave all 3 experiments the same task, the same agent, the same repo to work on, but using skills, 2 different skills, and I'm going to go into why, or using GitHub's official MCP server. Why did I pick GitHub for this experiment? Well, partly because everybody in this room uses GitHub. So it's an extremely relevant experiment. You're probably already using an agent to talk to GitHub every single day. GitHub also has a really mature official MCP server, a reference quality implementation, or is it? We'll find out. And GitHub also has GH, which is an extremely capable command line client. So both sides of this debate get their best shot. It was very hard to find a bunch of a popular service which had like a really good MCP server and a really good command line client, and GitHub is one of them. So it's the fairest possible fight, or is it? We'll find out. To have something to test against that didn't blow up like an actual GitHub repository I was using for something, I created a fake GitHub repository called Acme SDK Python. and I filled it with fake code that doesn't really work, but I gave it a bunch of realistic-looking GitHub repo activity. So I gave it issues and comments and PRs and milestones and like assignees and all sorts of stuff. And the code itself doesn't matter. What matters is the state of the repo, because that is what I'm getting the GitHub tool and the GitHub MCP to work with. I'm getting them to modify the state of this repo. I initially made this repo public, and as soon as I did that, somebody's bot showed up and found the tag called good first issue and started like desperately trying to fix my fake code. It was like, this is terrible. This doesn't even parse. And that, of course, blew up all my experiments because it was like it was creating PRs and things and modifying my experiments. So that was really annoying, but it does prove that it was a very realistic-looking repo because I fooled somebody's bot. Then I wrote 25 tasks across 4 tiers of difficulty. So the first tier is like stuff you can one-shot with one command. It's trivial reads. Tier 2 is slightly harder reads, where you have to do multiple reads to get enough data. Tier 3 is writes, which turned out to be the trickiest tier. Writes are very difficult for these bots. And Tier 4 was supposed to be the most complex tasks, where you do multiple reads and you do analysis and you do a lot of juggling of data. Stuff that you can't answer with a single command, stuff like, for each milestone, report completion percentage, or find all multi-label issues and tell me the most common pairing. So then I wired up 3 versions of the agent. I'm going to call them ARMs, because ARMs is just a term that people doing A/B tests use to call experiments. And the first ARM, like I said, is MCP. The agent gets the official GitHub MCP server, and it is firmly instructed to use that and only that. Will it pay attention to me? Agents are tricky. The second ARM is a GitHub skill that I pulled from a library of GitHub skills called LobeHub. This skill is an encyclopedic reference. It is 2,187 lines of markdown. It lists every GH subcommand with all of the subcommands and all of the arguments. It's organized like a man page. It is comprehensive. But then I thought, what if I just picked a bad skill? Then it's not a good test. So I decided I would pick a second skill as well from a list called the Claude Skills Vault. And the 2 skills look very different. The Vault skill is very short. It's 6 times shorter, and it's opinionated. It splits the commands into things that are safe and things that are dangerous and things that are reads and things that are writes. So it is a playbook. It's not just a reference. But the rules are the same for all 3 ARMs. They get the same agent. They get the same base prompt. They get the same 25 turns in which they're allowed to try and finish the task, and the same very capable Opus 4.6 model. The only thing that changes is what tools I'm telling them to use. So before I get into the results of the evals, for those who aren't familiar with evals, I should explain what they are. Basically, they are tests. I don't know why the eval industry decided that we were going to call these things evals and traces and like words from the ML industry rather than logs and tests, which is what they are. But with regular deterministic code, you can write deterministic tests. You can say 2 + 2 = 4, true or false. Did I get that right answer? But with LLM-powered agents, you can't do that. If your task is, summarize this text, then your LLM can give, a million possible answers, and half of them would be right, and you don't know which half, and you can't string match for the result. A human looking at the results, whether the answer is correct. But humans don't scale, and they don't run in CI. So the way to handle this kind of non-deterministic input is to use a tool that is very good at non-deterministic input, which is to say use another LLM to judge the output of your agent. And this is part of what Arize AI does. It provides a framework that lets you run these evaluations. And evals give you a way to objectively measure how well your agent is doing something so that you can make your agent better. That is what evals are for. Which brings me to a very quick plug for my employer. I apologize. Arize brings you a bunch of tools, a way to capture logging data called traces, and a UI to inspect those traces in detail. You can also run evaluations against those traces. So you can run the evaluations in development to make sure that you're shipping something good. You can run them in CI to make sure that every commit is good. Or you can run them against production data so that you can make sure that things aren't going off the rails while you're not watching. But more directly relevant to this talk, what you can do is you can take a subset of those traces and you can turn them into a data set, and then you can run experiments where you run the same tests over and over and you change one thing, in this case, the tooling. And you can track how your changes change the outcome of the task in a nifty little UI. So to test my Claude agent, I had to come up with 5 metrics. The first one is correctness, which is measured by LLM as a judge. Like I said, I know what the answer is for each task, so I wrote that down, and I got the LLM to look at the answer that the agent gave and see whether or not the answer was correct. Output quality is also LLM as a judge if the final response well formatted, not just correct. Latency is not an LLM as a judge. It's literally just wall clock time. How long did the agent take to complete the task? Cost is another very important metric for your agent. Is it costing me a lot of money to do this thing? And the last one is tool fidelity. For each arm, I defined an allow list of tools that it was allowed to use. And tool fidelity is what percentage of the tool calls that it made are tool calls that I allowed it to make, because agents, take rules as suggestions rather than rules. So that was, then I ran it 5 full passes through every task, every arm, a total of 500 tests, each one of which took many minutes to run. And I often had to throw away runs because things like, Claude would have some downtime, and then my whole experiment would be ruined because it was taking forever because Claude was down. Or I had to reset the repo back to 0 because one of my tests went wrong. Like, the whole thing took weeks. But now let's look at the results. Starting with the most important measure, did the agent get the answer right? Well, this is equally good or bad news for everyone. Everybody got roughly the same score when it came to correctness. Their score for correctness was in the high 80s. I would have preferred that it had got in the 90s, but I made these tests deliberately tricky. On tiers 1 and 2, which, like I said, were all reads, correctness was actually 100%. It was when they got to writes that the agents started falling down, and when they got to the tricky analysis, they really started falling down. But the core conclusion that you can draw here is the same. No matter what kind of tool you use, whether it's MCP or command line, you will get the answer eventually, but eventually turns out to be the real kicker. If you look at latency and cost, things are wildly different. Latency is way higher for MCP. MCP is taking way more turns to get the task done. More than twice as many turns, about 12 calls per task versus 5 on the complex tier 4 tasks. And because it's taking more turns, it's also burning a lot more money, because every time it takes a turn, it has to take the previous conversation and inject that back into the context window, which makes the conversation even longer, which means that it compounds. You burn a lot more money than just the latency would suggest. So this looks really, really bad for MCP, right? There are some extenuating circumstances, though. One is that the MCP server from GitHub is less flexible than the API that GH is using. For instance, instead of getting all issues for a milestone in one call, which GH can do, MCP has to make 2 calls, one for open issues, one for closed issues. But another one is structural. The response that the MCP gets from the MCP server is a huge pile of very verbose JSON. So what happened was the output overflowed the agent's context window, and it had to call again, and this time it had to write all of the JSON that it got to disk, and then it had to use bash and grep to read through the JSON, which is cheating, I think you'll find. So one of the really great things about using an LLM as a judge is that you don't just get binary test results. You don't just get yes, no, it passed or failed the test. LLM explanations accompany every single result. So you get a little LLM buddy who's watching every single test, who explains exactly what went wrong with that test or what went right with that test. So I was able to read these explanations and get full visibility into what was going on. And this is amazing because it means that LLM-powered evals tell you not just what your agent is doing wrong, but how to make your agent better. That is one of the really cool things about LLM evals. So in the early stages, it was mostly telling me ways that I'd messed up my test. It was like Claude hung, or you got this wrong, or your reset didn't work. But eventually, it became explanations of how exactly the agent was behaving in all tests. One particularly egregious example was test 22, which was find issues opened and closed in the same milestone and compute the average time open to close. So Vault, on average, got it done in 7 tool calls, under a minute, cost 19 cents. MCP, on its worst run, used 71 tool calls. And the worst part is that only 3 of those 71 tool calls were actually MCP calls, and all of the rest of them were the agent messing around with bash and grep, trying to parse these JSON files that it had downloaded. So not only was MCP taking really long, it was also cheating and using the command line anyway, even though I told it that it wasn't allowed to. So I anticipated this possibility. That is why tool fidelity is one of the tests here. So you can see that on all tasks, tool fidelity of MCP is not very good. It is using bash a lot of the time, and on the really complicated ones, it's even worse. But from a practical viewpoint, does that matter, right? Like, do you care if your agent is using bash under the hood if you're told it to use MCP as well? Like, I'm not really going to count that against it. Like, sometimes you have to use bash. But it's certainly indicative of a problem. And the fundamental issue here, or more accurately, the fundamental issue with the GitHub MCP server is that it's a fixed API surface. When there's an API call that does what you need, it absolutely perfectly one-shots it. If there isn't an API call in the MCP server that does what you need, then it has to make multiple calls, or it just can't figure out how to do it at all. The command line doesn't have that problem. Bash is Turing complete, so you can do basically anything that you need to do. And so that is how all 3 arms solved the problem, whether or not I told them to. All 3 arms were like, I'm going to use bash to solve this problem. But sometimes it goes the other way. Task 13 was to create a branch and open a pull request. It turns out there are 2 calls exactly for doing that. So MCP did it in 2 calls, but it took LobHub, which was the skill with all the context, 22 tool calls in nearly a minute and a half and almost 50 cents. So if you give it a thing that it's good at, it's very good at it. But despite that exception, like, our conclusion should be obvious, right? The command line wins, strike up the band, drop the confetti. Even the tool that was supposed to be, even the agent that was supposed to be using MCP was in fact using the command line the entire time. Does that seem fair to you? It doesn't seem fair to me, because the truth is a lot more complicated, or this would have been a very short talk. The first problem is that GitHub is really famous. So the GH tool is really famous. It's in lots and lots of blog posts. It's in Stack Overflow. It's in Reddit. It's in all sorts of things. So what happens if I don't use a skill at all? What happens if I don't use an MCP server at all? What if I just give the agent this task and say, you figure it out? So here's those tests again with a 4th set, using an agent with no skills or MCP instructions. And let me tell you, when I'd done like 500 tests, and then I discovered, oh, I have to do one more set of all of these tests. That was a discouraging day. It turns out Claude is really good at using GH all by itself. In fact, it's slightly better. The baseline is slightly better than with the skill in terms of correctness. And I asked the explanations, why is this? And it's because the tools, the skill files rather, they say, be careful doing something dangerous. Whereas if you just give it to Claude, Claude just one-shots that and it's just YOLO, does not care whether the tool is dangerous or not. And so it gets slightly better because it takes slightly fewer turns to do things. But on latency and cost, the story is different. MCP is still looking really bad. But both skills do better on latency than Claude baseline because they use fewer turns, because the skill file helps the agent make fewer mistakes. It gives it more information about how to use GH correctly. LobHub, which is the really verbose skill, it does worse on cost because it's burning more tokens because that skill file is so big. But the Vault skill, which is the short and finely tuned one, does a bit better than baseline on cost. So a skill does make a difference, and a good skill makes a difference versus other skills. But that is a really important point. The cost of MCP is partly because it uses more tokens, and the reason it's using more tokens is because MCP has all of this context about how to use the tool. And it turns out that for GitHub, at least, the model mostly doesn't need all of that context. It already knows how to use the tool. But that's not going to be true about your CLI. Your company is probably not as famous as GitHub. It's probably not as well documented as GH. So your CLI is probably, your agent is going to have a lot more trouble using your particular CLI for your particular service. It might not be able to figure it out at all without the extra context that MCP provides. The next confounding factor is that MCP is not supposed to be just a thin wrapper to your REST API, although that is what a lot of MCP servers are. MCP is a very rich protocol that has tools and resources and prompts and all sorts of stuff that helps your agent do better at using the tools than just a skills file would do. But more than that, an MCP server can have a whole agent behind it. MCP is an LLM native natural language protocol. So instead of having to make all of these tedious tool calls, my agent could have been able to just say, hey, give me all of the issues that match these criteria and filter them for me by these other criteria. And an agent on GitHub's side could have done all of that work and given back the answer and one-shotted it. This could have been a collaboration between agents. GitHub's MCP doesn't work that way, but there's no reason that it couldn't work that way, and there's no reason that your MCP server couldn't work that way. So that changes the story considerably. And finally, there's an elephant in the room, which is auth. CLIs are inherently developer tools. GitHub is a developer tool too, so that's fine. The average GitHub user is going to have no trouble figuring out how to generate an API key and passing it to the GH tool. But LLM users are the whole world. That's what we've been learning recently, is that everybody is using agents now. And asking the average user to generate an API key is kind of pushing it, and asking them to open a terminal and put that API key into some kind of config file is way out of the question. They are not going to figure that out. They are just going to say nope. So your agent is probably not going to be able to use a CLI because the operator is not going to be able to use a CLI. And even if it could, it probably couldn't figure out how to use a CLI because CLIs are so different. They're not standardized. And also, the level of access control provided by your average CLI is wildly different to what your enterprise admin is expecting to be able to control. MCP, on the other hand, uses OAuth. In fact, it uses OAuth so extensively that they had to extend OAuth to be able to do all of the things that MCP needs to be able to do. And the result is actually a really great experience. You can just paste the URL of an MCP server into your average agent, and it will figure everything else out. It will discover stuff. It will pop open a little browser window that asks you for permissions in a nice, friendly, usable way. And then everything just works. This takes MCP from being a developer tool to being a consumer tool. This is something that the normies can use. OAuth also allows enterprise administrators to finally control who gets access to what and where and when and stuff like that they need in a way that API key-based authentication is usually not designed to do. So is MCP? I don't think so. If a developer using a developer tool, the evidence is strongly in favor of skills. That, especially if you are using a widely known service. That is the narrow conclusion that you can draw from this data, is that for developers, skills are usually the right way to go. But the overwhelming majority of agent users are not going to be developers. They are a regular consumer product. They are used by people who are using Claude and ChatGPT. And MCP is not only the best option for them, it is, practically speaking, going to be the only option for them a lot of the time. Which brings us right back to the beginning, which is MCP versus the command line. This turns out to be the wrong question. It is MCP plus the command line. Real agents use both. Claude Code uses both MCP and the command line, depending what it's trying to do. Cursor uses both. Your agents should probably be capable of using both. Use the CLI when you are working locally, when the tool has decades of training data behind it, when auth is pre-configured, when you benefit from piping things together. This is the automating my own workflow case. Use MCP when the tool is remote, when it's proprietary and not in the training data, when you need OAuth and per-user auth, when there's real state to manage across steps, and especially if you want to hide an agent behind your API. This is the shipping it use case. So my headline findings are real. MCP collapses on open-ended analysis. 6 times the cost on the hardest tasks, 5 times the latency. Skills help a little bit. A short opinionated skill is going to help the most. But for a popular CLI like GH, the training data is doing most of the work. But MCP is not the loser of this story. Testing with evals did what testing should do. It showed us the limits of our original question. And our job as engineers is not to pick the winner in a Twitter fight, as satisfying as that may be. Our job is to use the right tool for the job. So if the model knows your CLI, if you're running as one user with one set of credentials and your task is composable, use the shell. If your tool is remote, proprietary, needs real auth, then use MCP. And in most real systems, you're going to end up using both. I hope this has been a useful look into what tools you should use, tools you should actually use and how you should use them. And I hope it's given you some insight into how evals can help you improve the quality and functioning of your agents. All of the code and the data that I did here, so you can double check my work, is open source on GitHub. And that's all I've got for you today. Thank you so much for your time and attention.
Can you believe that? We're down to our last talk. Okay, let's do a little poll. Who here uses Cursor? Yes, okay. Do you know Cursor has a CLI? Anybody knows that? Okay, one person, okay. So our last speaker for today is from Cursor, David. David is a software engineer, and he's living a dream. He works for Cursor, and he lives in Madrid. And he has been doing programming for the longest time, even doing competitive programming back in high school and university. So he's also an avid runner. He'll be running on Friday at the React conference. So if you're staying, you can go for a run with David as well. But before we go to the run and go to the after party and everything, we're going to welcome David onto the stage to talk a little bit more about how he thinks that IDEs are dead. Long live IDEs. Tell us more about it.
Hello, everyone. Let's just get things set up. And just full screen this thing, and we are ready to go. Okay. Welcome, everyone. Thank you for joining me here today for the last talk of the conference. I hope you've all had a blast. I know I did. And I'm going to keep it short, especially short, because I know you all want to go explore Miami and get dressed and ready for the after party. So a lot of you might have heard that IDEs are dead. And I think that's partly true. And today we're going to be talking about what it means for IDEs to be dead and what I personally think is the future of IDEs, as well as what we at Cursor believe is the future of IDEs. A little background on myself. I'm a huge IDE nerd. My very first programming project was an IDE. And in fact, I was doing some research yesterday, and I actually found it. I hadn't looked at it in a long time. It was called Croquette. It was an IDE for a programming language that doesn't even exist anymore. It was called Axe. And this is what it looked like. Very, very basic. But that was 2011, right? We've come a long, long way since then. Also, I forgot to mention at the beginning, I love running, and on Friday I'm hosting a 5K with the Neon folks, my former employer. And we're meeting here in the hotel at 7:30. So if you're around, please join. OK, back to regularly scheduled programming. When I started coding, there weren't that many IDE options. Everyone that I talked to at the time was either using Emacs or Vim. And it was kind of like Harry Potter. You got picked into a house, and that was where you went to. And for me, that was Emacs. For no real reason, like, I think my decision was basically like Emacs is a UI and Vim was in the terminal, so it felt more scary, so I just went with Emacs. I also spent a bunch of time on Genie, if you've heard of it, and then also Eclipse. But I basically used everything. I tried everything, and I spent a bunch of time with all these different editors until VS Code came out. I think it came out in 2014. But I think 2017 is when it got really, really good. And the reason why I moved to VS Code, even though I was like a diehard Emacs fan, is because VS Code made it so much easier for me to try new programming languages. The problem with Emacs is that every time I wanted to try a new programming language, I would spend a week just configuring Emacs for that new language. And with VS Code, that wasn't a problem anymore. And that's what got me sold at the beginning. But then over time, VS Code kept getting better. The extensions API really improved. And I became as a diehard VS Code fan as I had been an Emacs diehard fan. I put in a ton of time into my VS Code configuration. I have over 500 lines of VS Code config, over 500 lines of just keyboard shortcuts as well. So I have like fully customized my VS Code, and it doesn't even look like VS Code anymore. And then after way too many people told me to try Cursor, I eventually caved. Now, but I really resisted it. Like, I was so scared of moving away from VS Code that I never installed Cursor, even though everyone I knew was already using Cursor. And I just really resisted it until I was sitting next to someone and I saw them use Cursor, and I thought, I have to try it. And I think in the beginning, just like most people, what really got me to love Cursor was tab complete, right? That was like the first Cursor feature that really had everyone fall in love with AI coding. And the funny thing is, I was recently looking at my tab usage, and I joined Cursor in September, right? So you can see in this chart, you can see that in September, I used tab 1,400 times, and then in December, I used it 9 times. And I didn't take time off in December. This is my real tab usage over my first 4 months at the company Cursor. And I think if the chart went further into 2026, my tab usage is probably 0 right now, not even 5 or 9 as it was in December. The truth is, there's a lot of things from the old IDEs of Emacs and VS Code that we don't need anymore. You might remember that we spent years building and configuring text editors for maximum comfort and maximum productivity. There are options such as whether parentheses should auto-close or not. When you type quote or when you open a block with a bracket or a curly brace, should it auto-close or not? Should the cursor blink? And if so, how many, what should the interval in milliseconds be? Should your scroll stick? And if yes, by how many lines? And how long should the lines be? 80 characters? 200 characters? Most of these things don't really matter anymore. And they actually are detrimental to the performance of IDEs, because when you have settings that look like this, where you can even configure which quotes and brackets have auto-closing and which ones don't, the problem with having all these settings is that you introduce basically factorial level complexity into your product. And it makes it harder to test the product and makes it harder for the product to be stable. So if you look at VS Code, for example, it has 1,000,000 settings. That's why I loved it so much, right? That's why I became such a diehard VS Code fan, is because it let me configure everything. A good example is the minimap. So the minimap in VS Code is this little minified or zoomed out version of your files. And just for the minimap, VS Code has more than 10 different settings that you can configure. That's a lot. And it means that the developers that work on VS Code have a really large and broad surface area. And that makes it really hard for us at Cursor and for the people at Microsoft working on VS Code to innovate, because you just spend so much time fixing bugs, testing all these different configurations. We simply don't need all of it. Agents are now writing 99% of our code, which means we have to rethink IDEs. But if we are going to rethink IDEs, we have to start from first principles, and we have to think, what do we still need? What kinds of things are necessary for the current age of AI programming? And one idea is what if we just go completely bare bones? We just remove all the distractions, and we just have a chat. And if you've ever used the Cursor CLI, that's what it is. That's what the Cloud Close CLI is as well. That's what the Codex CLI is. These are just the most raw, simple interface that you can have for AI coding. And they're nice. I like the Cursor CLI. I actually use it every single day. I use it a lot to build this presentation, actually. And I just tweeted last week that I use it every day. But ultimately, I'm only using it for 5% of my agent. I need more than what the CLI can give me. And the kinds of things that I need cannot really be rendered in a CLI. I need video playback, because most of my work nowadays is watching videos produced by agents to verify and assert that the work they did is correct. So I need video playback. I need image rendering. I need to be able to annotate images, annotate videos. I need rich interfaces, such as mermaid diagrams, knowledge graphs, and charts, which I use for testing things, and as well as for data science and other data analysis work that I have to do. I need the browser, and more importantly than just the browser, I need the Chrome DevTools, and I need the Chrome DevTools debugger. I need all these rich interfaces that just cannot be dumbed down into a basic chat. Mobile developers need emulators, and they need both iOS and Android emulators. We need native system notifications that tell us when our agents are done. And then finally, last but not least, we have to edit code. I'm not saying agents write 100% of my code. They write maybe 97, 98%. And for those 2% of my lines of code that I'm still writing myself, I need a basic code editor that functions well enough, that is decent enough, has code definition, language server protocol, other types of useful features. So I do need a decent editor. And all of these things combined is, I think, what we need for the IDE of 2026. Another thing is, for the most part, and this is my own personal data of Cursor. More and more, I'm not running my agents locally. So you can see I joined Cursor in September, and this chart begins in November last year. And this is how many agents I'm spinning up per day. And you can see a clear trend that more and more of my agents are cloud. So less and less my computer is the bottleneck for performance, and more I'm letting the agents go and run for longer remotely. So what do I do in my IDE? Well, I watch videos, right? I am asserting that the agents do what I'm asking them to do. I work on the Cursor product interface, so I do a lot of front end, and I spend a lot of time just watching these videos. I use the browser, right, to verify my work, test things, play with what I'm building. And then I need rich interfaces, right? I need charts. And I actually use the Cursor Canvas feature quite a bit to do data science, right? If you haven't used it, it's basically a feature where the agent can generate on the fly, single purpose UIs that can go away after you don't need them anymore. Now, you might remember Cursor 2.0. That was actually the first project that I worked on when I joined Cursor. Literally in my first week, my former manager said, hey, welcome to Cursor. We're building a new UI for agents. And I was quite excited by the possibility of rethinking the interface for coding. And at the same time, I was a bit skeptical that I would be so hands-off with my code, right? But lo and behold, after a few months, I was barely typing any code at all. It looked like this. It was pretty basic, and we launched in late October. And we didn't get as much customer love as we wanted to with this iteration. It had some nice things. It had work trees. It had parallel agents. And that was also when we introduced our first company model. But it didn't, again, get as much love as we wanted it to. Even though more recently we added this super complex layout so you can tile and manipulate terminals and files and chats, and you can have these grids of 16 by 16 agents if you want to. But even with that, like, we still didn't feel like the interface was malleable enough for what we wanted to give to our users. So why did we start from scratch? If you've heard about Cursor 3.0, which we launched 2 weeks ago, we basically took a from-the-ground-up approach to the IDE interface. And the main reason why we started from scratch was to break away from the VS Code baggage, right? The VS Code layout system, the VS Code architecture. We needed a blank slate. We needed a white canvas, right, where we could innovate from first principles and build the IDE interface that we really believe is right for most people. And then the other reason is that by starting from scratch with a new UI, a new window, our users can gradually adopt it, right? You can have both the traditional VS Code interface open as well as the new agent window open at the same time. You can hop between the two of them, or you can just use the new one, or you can just use the old one. But with this model, we're not annoying anyone by forcing them into a new experience. Everyone who loves the VS Code interface can stay there, and then the people who want to use a new interface can use it as well. So that gives us a lot more flexibility as well as a lot more room for innovation. First thing I'll say is it's missing your feedback right now. So the only way that we can keep iterating on the IDE interface and make it better is by listening to our users. That's how we build our product. We continuously listen to user feedback, we iterate, we launch new versions, and we do this in as tight of a loop as possible. So the main thing that is missing is really more people using it. The more people we have using it, giving us feedback, the better we can make it. And then the other things that we're really excited about are better handoff. So for example, handing off agents that start on your phone, that go into the cloud, that you then pull into your computer. Maybe you move them into a work tree for a little bit, and then maybe back to the cloud, and then maybe you finish them from your phone. That kind of handoff needs to be seamless and very powerful. We also need more orchestration tools, because the more high level we go with our AI coding techniques, the less time we'll spend reading all of the code necessarily. And so we need Kanban style, DAG style UIs for orchestration, where you can develop plans and split them off into multiple agents. Better mobile support is something we desperately need. I know a lot of people use Cursor today for mobile dev, and they have to have Xcode open at the same time, and they keep popping back between Cursor and Xcode. Nobody should be having to do that. They should just be able to stay in Cursor the whole time. Computer use. We have great computer use in our cloud agents, but we don't have it locally yet. That's something we're working on. The idea here is that the agent can interact directly with your product. We allow this in the Cursor browser, but not for desktop apps. And then we need much better code review. That is, for me, one of our P0s at the company right now is we're not writing any code, but we are reading a lot of code. I know most of us are probably still reading 90+% of the code. However, the UI for code review needs to be rethought as well. And then there's many more things that we're also cooking in the background. So I'm going to say it again, really importantly, please send us your feedback. My DMs are open. You know where to find us. We're a very open company. And please try the new interface. I was actually sitting next to someone yesterday that had never tried it, and I was just like asked them to please click the button. I just want to see you use it. If you have feedback, also just come ping me. And yeah, thank you for taking the time to listen to me today.
Right, all right. Can you believe that this is coming to a close and you've stayed till the very end? So, wow. Okay, so we're gonna do a closing remark. And for those of you who are live streaming, also stay tuned because we're gonna bring up some really cool people for the closing remarks. Okay, so just a couple of shout outs. Which talk really inspired you? Give me some names, some topics. Memory? Which one? Oh, Alvin Pane. Yes, yeah, I heard that one. Anybody else? Code mode? Yes?
You're not the speaker, are you? Okay, no.
We can't really see you, sorry. So if you are the speaker, you can also shout out your talk. Which one? Codex Spark.
Oh,
yeah.
Sure,
Yeah.
sure.
Yeah, keep messaging Gabe for sure. Okay.
MCP versus CLI, yeah.
Yeah.
Good one.
Anybody is excited to try something new after the conference? Yes, okay, a couple of people, okay. That's the energy that we're looking for. We really hope that you learned something new, made some good connections, and you're really excited about building a better future with AI. So that's kind of what we want from this conference for you.
Yeah, and it was truly an honor and pleasure to be MCPs for this year's AI Engineer Miami.
The MCP? Ima, are you becoming an MCP?
What is that? What did I say? Okay. I'm tired. You see, I'm performing at 20% energy now. But it went so fast, and it was all thanks to you. You're awesome, and you made it easy for us. And I would like to also thank everyone on live stream. And the videos are gonna stay on YouTube. And that's the whole idea behind this, to enable many people to leverage AI in their lives and in their works. Also, I want to leave you with a thought that it's true that AI is really making us much more powerful, and the same scope maybe can be done with fewer people. But who's to say we have to keep the scope limited? Let's tackle bigger problems. Let's take on much bigger problems that we perceived to be impossible before and go for that. And if there is a day, and a day comes that there are no more problems, we'll all go to the South Beach and play the guitar, and nobody has to work, right? So let's try to solve much bigger problems. And yeah, I feel we have this community here. It was really lovely to be a part of it, and I hope to see you all next year. Who's coming next year? Who's planning a
Yes, that's the energy that we want.
There you go. Back to you.
Yeah, well, so the party doesn't stop here. First of all, there is an after party at Thrill Social at 7 p.m. So if you want to continue the networking, feel free to come join us. Say hi to your favorite MC, not MCPs.
MCP servers, MCs.
And there's also more activities going on this week. So how many of you are going to go to the React Miami conference? Yes. So the party continues. So keep making connections. Really keep an open heart. Apply the things that you have learned, make new connections, and really build amazing things with AI. Okay, and this conference wouldn't be possible without our organizers. So now I'm gonna invite our favorite organizers onto the stage, Michelle, Gabe, and Rebecca. Woo!
Wow, this is awesome. It pinched me. Did this just happen? It did. Thank you so much for coming. First, like a shout out to all you and the vibes that you brought. They were all beautiful, positive, and it's only going to get better at around 6:30 with a slight amount of inebriation and tacos. And I want to thank first, Swix and Ben and Leah at AI Engineer. Please give them a round of applause. This would not be possible without them. Like Swix early days, JavaScript days, 6, 8, 9 years ago, he wanted to care for the community, and he wanted to provide signal content, in the at the time JavaScript space. And so I just, Swix, wherever you are, thank you for your heart and allowing us to be a part of AI Engineer Miami. This also would not be possible without these amazing sisters up here, Michelle and Becca. You crushed it. Any sense of like, this is actually for the community, not just a cash grab. It comes from these two right here. They have led this process in Miami for the last 5 years, right out of COVID, when nobody thought this was possible. And just thank you for what you do.
Thanks, Gabe. Yeah, you guys are our heroes. Thank you so much for showing up for year one. a round of applause for yourselves, actually, very quickly. Like, please, thank you. We appreciate you so much. And Gabe, I'll pass it back to you because it wouldn't have been possible without G2I and you and provide knowing what this was and the impact it could become. So you trusted with React Miami, and now we're doing AI Engineer Miami, and this is incredible. So thank you, Gabe. Thank you, Gabe. We appreciate you. All right, and we're going to do it again next year. But before next year, upcoming is AIE Singapore in 4 weeks. Is anybody going to go to Singapore in this room? I mean, it's a very full, I want to go. Yeah, okay, the live stream. So 4 weeks, you still have time to get your tickets. It's going to be amazing. We're really looking forward to it. And without further ado, do you have anything you wanted to mention? Let's party. All right. Wrap it up.
And see you at the after party.